that I see you. Kelly,
Morning, Kelly Summers, EPA Region 3.
Andrew,
And I'm assuming me, Andrew Holmesy, University of Delaware Water Resources Center.
Marianne,
Marianne Walsh, recently retired from the center.
Doug,
Doug Janik with Sovereign, West Chair STAC. I'm sorry I couldn't make it in person since it came up last minute yesterday afternoon. It held me up local.
we're glad you're here with us online. Alex,
Good morning, everyone. This is Alex Soroka. I'm a physical scientist with the USGS based out of Baltimore, Maryland.
Suni,
Hi, I'm Suni Walter. I'm at the University of Delaware. I'm a geochemist.
Jen,
Jennifer Walls, Department of Natural Resources, Principal Planner.
Zena,
Good morning, Zena Hentz, DenRec, Division of Fish and Wildlife.
Kristen,
Good morning, Kristen Kowaleski with Interflu.
Olivia,
Good morning, everyone. Olivia Allred with DenRec's Watershed Assessment and Wetlands Program.
Holly, Holly Walker, are you able to meet and say hello? She may have stepped away. Mike Bott,
Hello, Michael Bott with DenRec's Division of Watershed Stewardship.
Robin,
Good morning, all. Robin Glazer with the Delaware Nature Society.
Ashley,
Good morning, Ashley Tabibian with with DenRec Shellfish and Rec Water Programs.
and Lori.
Hi, everybody. Lori Brown with DenRec Division of Watershed Stewardship as well.
Did I miss anybody? I see there is a phone number, a 302-612. That person, somebody that we've already met and called in as well, or is that somebody else? Or will remain a mystery. Okay, I'm gonna ask if everybody that's virtually, would you also mind for our note taker, which is Rich, if you could type in your name and your affiliation and into the chat as well, that'll help us with our notes so that we get a better record since you're not signing a sign-in sheet for us here. So I really appreciate that. I think Anna is also on. Oh, Anna, I missed that. I skipped right over you. Sorry, Anna, please.
Good morning, no worries. Anna Fagan, I am Deputy Director and Acting ED for the center.
Thank you for pointing that out, Megan. So welcome, everybody. I'm glad we have a great group here today, a nice in-person contingent as well as one online. We're going to jump into our agenda. First up, we are going to press an announcement. So we briefly had Megan wave and say hello. She's going to give us a little bit of an introduction to herself. Okay, that's takes that online. Is that not in the phone?
I don't think that's on.
Oh. Pause 1 second for technical. So I will say the interesting thing here is the online. We're seeing the slide view, like your slide sorter page, and not the presentation page, which we're seeing on full screen. And I don't know how to fix that. I don't know what. Can folks online hear her?
No.
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 So I think you're gonna have to reshare your screen and. How about this? Is it it's supposed to come out of the little thing?
Yeah.
It's supposed to come out. Oh, well, then we'll just talk about it. Nice and loud. Again, my name is Megan Dory-Fellows. I am new to the center. So Megan, are you able to share your screen again? I will, unfortunately, Microsoft is asking for us to things at the moment, better inconveniently. We'll see if it works for to start in 5 minutes as well, because that would be the top, right? So I am new to Delaware, but I am not into estuaries or restoration ecology. The key for me really in that sharing now? Yep, I got it. The key for me is kind of strategic thinking about ecological restoration. Knowing why we're doing something, how it fits into the big picture, and how does it further science down the road. And by training, this reflects the early stages of restoration ecology, where we were focused on adaptive management as a solution to everything. Where we monitor, we learn, we change, and then we progress. This seemed a wild idea at the time, but now taking action based on science is a very logical solution to our activities. But that's where my training is, and so that's often kind of where my brain goes. How do we learn what we do so that we can improve? And if you're like me, better in pictures, we plant trees specifically to improve water quality so that we have downstream benefits to the invertebrates that live in the water. And then you can learn how to plant trees better. You can learn how the interaction trees and water quality interact. There's all sorts of different angles that you can learn. You can draw spaghetti diagrams and charts. But the goal at the end is to do better. And I do this by finding where we can work together, where everybody gets the win at the end of the situation. And you don't have to force every opportunity, not every partnership. Sometimes someone just has to go and do it, and it can't be everybody working together. But as long as we're working towards the same outcome, we can agree on that outcome. And key to that is flexibility and modification, but if we have many hands, we can make a load a lot easier. Most recently, I was focused on stream restoration, actually in-stream restoration, focused on assessment of streams, prioritization of which stream, project management, construction, implementation, and where my heart lies, and monitoring so that we can learn how to do all of that other stuff better. I also worked on reforestation for water quality as well as other benefits, and really focused on creating forests, not just tree plantings. And so this schematic is one of my new inflation plot techniques for reforestation. And then the final major focus area was understanding multi-metric restoration outcomes across disciplines in a way that you can convey it simply and easily to the general public, as well as funding agencies and others. And so this is a modification of the Society for Ecological Restoration Recovery Wheel. And in this slide, or in this one diagram, you can see where our values for the restoration are, how we've made progress, and how the design will go and meet those progress. And then after the restoration, you can go back and monitor through time to see if you're making progress along those strategies. So it's scalable and adaptable. This work has led to a couple of significant outcomes, including guidance bay restoration, improving the individual practice of various restoration practices, engaging partners, collaborators in united efforts to share outcomes and goals, enhancing efficiency and workflow within my organization, as well as guiding monitoring schemes and crediting assessments for restoration. So this kind of sums it up. Used to say I don't even see the box, but I'm really open to new ideas and innovation where we can make progress down the line. So if you have any ideas or how we want to move forward, I sort of see the next 6 months where you're really understanding where the ideas, where the staff is, where we want to move forward in the program, and I really look forward to working with all of you to make that happen. We really look forward to working with you too, and I can say I've really enjoyed getting to know Megan a little bit over the last month, and I think we've got a lot of fun things to work on in the future. So welcome. We're so glad you're here. There are other staffing updates too, correct? Did you want to cover that, or Susie or Anna? I don't know if anybody else that's here from the center is planning on doing that. I think Anna was going to. Right?
Yeah, happy to share. Very exciting news in that all vacant positions at the center, with the exception of the executive director position, have been filled. So we're very excited to be operating at almost full bore. In terms of the executive director search, our search committee conducted second round interviews with our top 2 candidates. This involved bringing the candidates out to the center so that they could see some of our projects firsthand, as well as meet program directors. And as a result of those second round interviews, the search committee did reach a consensus on our top candidate. We are pursuing sort of the next steps associated with that, which involves sort of your standard, reference checks, background checks. So hopefully we can share some good news and some more details with the full committee soon. And I just want to give Susie an opportunity to weigh in case she has anything she'd like to add.
I'm excited about our top candidate and just hope that all goes well in that process. And I think we've chosen somebody who can just come right in and start working without too much of a learning curve. So that's, I think, going to be very helpful for all of us.
We are excited to hear more, and I understand the plan is probably that the new executive director really wouldn't assume that role until the start of the new year.
Correct.
So,
yeah.
Just so everyone is aware of the timeline and the update. So we really appreciate being kept in the know.
Thank you.
Are there any other announcements from the center? Any other events or anything coming up?
I would just like to provide a quick update on the bipartisan infrastructure funding. I know we talked a little bit about that at the last STAC meeting. So center staff have prepared the draft work plan to be submitted to the EPA prior to October 24th. I think that the board is very close to approving that or has approved that work plan. Is that right, Susie?
The board has approved, yes.
Excellent. So the work plan includes $500,000 for the hydrodynamic and water quality model, which I know is a big focus of the STAC. So, very excited to have some considerable funding lined up for that project. And then I will make sure that we share the full work plan with the STAC following the meeting so that folks can review and see what other projects we've selected.
Anna, I was saying, I was speaking to someone else within the last week from another organization who is also getting some of this bipartisan infrastructure law funds, and they're doing similar types of work. And so I hope all organizations working on conservation and restoration can kind of touch base and really leverage those funds so that we are making a huge impact. So I think it's exciting that this is coming. And I'm glad you brought that up and mentioned it, because we do want to reinvigorate our modeling subcommittee. That's something that, for those of you who maybe served on it previously, you'll be hearing from us, and if anybody else who is interested in this next phase of actually seeing some of this modeling work come to fruition, please reach out, let me know, let Megan know, and we hope to have kind of a catch-up meeting before the end of this year, just to sort of rehash where we have been with this modeling exercise and where we are now, as well as where we want to go in the future. When we talked at the last staff meeting, there was a general consensus that there's interest in trying to take whatever funds would be available, which is not enough to do the entire hydrodynamic and water quality model for the entire inland bay system, but focusing on maybe a subsections, perhaps the Indian River, and start working there, pilot it there, and then we can build out as time goes on and additional funds become available. So we're thinking, well, this group could help us come up with what those priorities are, develop an RFP, and then we'll have really our plan in place for when the funds come in. So again, if you're interested in participating in that, please reach out. And if I don't hear from you, but you're on our list, you'll be hearing from me. The only other thing I wanted to touch base on under old business, and Marianne, not to put you on the spot, but I know you were going to be kind of working contractually on State of the Bays. I don't think there's really any updates other than you probably now have more time than ever to work on it. So, is there anything to inform the membership about?
No, I don't really have any significant updates. We're furiously writing and trying to finalize this. So we're looking at a release after the first of the year.
Okay, perfect. Thank you. Let me just get over, check the agenda again. I think that is it. So our first speaker, we're going to have to shuffle around the order of presentations a little bit here. Our first speaker, Dr. Matt Parker, had a childcare issue come up, so we are going to, you could go first, Scott?
Sure.
And Andrew, so we're going to have Scott and Andrew go first. We're going to bump them up on the agenda, and then we'll try to get back in order again.
Keep it over here. How's the volume for everybody?
Better.
Better, okay. How about folks on screen? You can hear me all right? Thumbs up is fine. Thumbs up, okay. Okay, so myself and Scott are going to present on something that I think STAC is pretty familiar with. Some of the results and discussion from our continuous water quality monitoring network that we've been running for the past couple of years.
Andrew, can I pause you for a second?
Sure.
We're having the same issue where you're not in full presentation mode online. I'm gonna have to stop sharing and then. No, now we're seeing, well, okay, once, maybe it's coming.
Let's try it like that.
So nothing's changed on this. Oh, okay. Zoom room's good up here, though we're seeing your notes.
Yeah, that's okay. There's nothing up there that's super confidential in my slide.
But it's small for us. I mean, is that?
I think we're gonna run into one or the other.
There you got it, right? How'd you do it?
Teach us your ways.
Sure, was it luck? Sure.
Let's try that. Folks on Zoom?
There we go.
All right. Okay, cool. So the center, in partnership with Project Wicked, has been continuously monitoring water quality at a number of different locations. We're now up to 6 full stations. So we have 2 in Indian River, 1 down here by Swan Creek, 1 in concert with the Delaware Seafood, 1 off screen at Pepper Creek, 2 in Rehoboth Bay now, so 1 up in Guinea Creek, and new for this year, 1 in Dewey Beach at the Rehoboth Bay Sailing Association. And then a 6th station we brought online was down in Little Aswoman by the coastal kayaks. So why is this work important? DENREC collects grab samples for dissolved oxygen. This is a plot of grab samples from the Swan Creek Station in Indian River. And you can see right about that 2009 timeframe-ish, the grab samples started coming back over the standard and remained over the standard for a number of years. And so this station, which was previously listed as impaired for dissolved oxygen, was then delisted and lost its, lost its status as impaired. And so it was categorized as supportive of aquatic. However, we know that the Indian River has large algae blooms, has on occasion suffered from frequent large-scale fish kills. And so the question became, is it really supportive of aquatic life, or are the grab samples not capturing the true conditions? So when we take a look at the continuous data from that particular area, the plot on the top left is a small snapshot of that continuous DO data from 2020. We see the typical hypoxia pattern, super high dissolved oxygen during the day, very low dissolved oxygen at night and early morning. This particular hypoxic period was linked to a fish kill. And so the delisting seems to not match with what the continuous data is saying. I do want to call attention to the dissolved oxygen plot on the bottom right. So that's the daily mean plot. It's very important with this continuous data to look at it in its full time series rather than looking at it on an average daily mean scale. So if you look at it on the full time series, you can see that hypoxia patterns. When you look at it on the average daily means, that pattern is completely mapped, and you get a much different view of what the dissolved oxygen is over. So that data from that particular SON was shared with DENREC for the 2022 305B report, and it was included, and it did result in the relisting of that segment for dissolved oxygen here. So this was a huge accomplishment for us. I think it's very important work for the region to start incorporating this continuous data into the actual formal systems. This has direct implications for federal funding. Very important stuff. So we'll have data from at least 6 stations to share for the next report. So more on that in future years. All right, I'm going to transition a little bit, start talking about some of the QA standards and actual results that we're seeing. So the plot on the table on the left here shows the maximum allowable drift that we have agreed with DENREC is allowable for use in the 305B reports. So we haul a sensor out of the water. It's been deployed for a week or 2 weeks. We take a reading with that dirty sensor, dirty quotes sensor, and compare it to either a known standard or a measurement taken with a cleaned and calibrated SON. And we record that difference if there is. So just for example, the dissolved oxygen from our already deployed sensor is allowed to be plus or minus 0.3 milligrams per liter different than what a cleaned and calibrated SON would read in the same bucket. The important thing to note here is that the actual drift values are preserved in the database. So we can retroactively tighten or loosen those QA standards to meet whatever the end user's needs are. So if at some later point in time, DENREC decides that those standards need to be tightened, we can make that change and retroactively have data up to those standards. Or if a grad student needs to take a quick look at the data and doesn't need it to meet these regulatory standards, they have a much looser need, then that's doable for us as well. Okay, so how are we doing in regards to meeting those QA standards? So this is the table showing the percentage of deployments that meet those particular standards. So in a given year for a site, we might deploy about 30 times, and we record the accuracy of each of those deployments. And so what I'm seeing are really great QA results. So 80 to 90% of our deployments are coming back for each parameter having met those regulatory standards. I think all of this work can be attributed to Zach, who's been doing this work for 3 years and has really developed a knack for how to deploy these, how to maintain them, and how to get them to stay in water for long periods of time accurately. Okay, so for the actual analysis, I'm going to talk about 2 different branches of methods here. So the first is the 305B methods. These are the ones that are actually used in the formal assessment. These methods come from a USGS document, and while statistically robust, they are loosely tied to biological thresholds. And so, for instance, the 10th percentile of your station daily average is not directly tied to some behavioral response in summer. Then there's what I'm calling biological metrics. Those are also not explicitly tied to a specific species response. Those metrics are more designed to get at the frequency and then the duration of hypoxic or loop events. They're also a little bit more publicly understandable as opposed to like 90% confidence interval or your percentile of your station daily averages.
Oh, I was just curious about the 305D first column. Is it 2 or more? If it's an instance, it's not less than 4. We'll flag the site doesn't have to be a daily average.
Does not have to be daily average. No. But for the continuous data, we are using daily averages.
Okay.
Yeah. So yeah, I'll talk about these. So for the 305B method, the first is taking a station daily average, which in Denver's case is just a single sample. For the continuous data, it's all data pooled together. Only one of those is allowed to be less than 4, otherwise it would come back as flagged as having it there. The next is calculating a 10th percentile of those station daily averages, and then 98% confidence interval on that 10th percentile, and that has to be above 5 or else it will be flagged. Both of these rely on station daily averages, so pooling all of that continuous data, as opposed to the only 305B method that's independent of calculating a daily average is the first percentile of all of your observations. So every measurement you take in at that for that given time period. The biological metrics, most of you guys are familiar with these. The CID has been using them for a while. Percent of summer mornings for DOs less than 4, percent of summer mornings for DOs 2. And then to get at duration events, we're looking at the number of instances where DO is 4 or less for at least 6 straight hours, or the number of instances where DO is 2 or less for at least 6 straight hours. So 6 hours is totally arbitrary. It was chosen originally because it's approximately 1 tidal cycle. So for the public to understand, this is from a high dual level to bid hypoxic. Okay. So for the results, there were 4 stations in 2021. Delaware Cultured Seafood and Warden's Bluff are in the Indian River. Robin's dock is in Guinea Creek, and then Fisher's dock is in Pepper Creek. There are a lot of numbers up here. I'm just going to call attention to a few that are of note to me. So the number of instances where DO is 4 or less for 6 straight hours is pretty astounding. So our best site still had 29 instances where DO is less than 4 for 6 consecutive hours at minimum. And at our worst site, 70 instances. The number of hypoxic events is also a bit eye-opening. So Warden's Bluff had 20 hypoxic events that lasted at least 6 hours. So that's an enormous amount of hypoxia for this period from October. The good news is that the biological metrics here, these last 4 columns, would suggest to me that there is a developed oxygen impairment in these individual water bodies. And the 305B methods return a similar distinction that these areas are not supportive of water life. And so that's good that there's not like a direct conflict between those 2 methods. I do want to highlight one potential pitfall. I do not feel that using station daily averages on continuous data is an appropriate way to look at continuous data, because you're taking away the highs and the lows, which are the things that you're most interested in when it comes to soft oxygen. Potential pitfall of that is here. So Warden's Bluff had 20 instances where DO is hypoxic for at least 6 straight hours, and yet that 10th percentile of station daily averages comes back as supportive of aquatic life. And so we're putting a lot of emphasis on the first percentile of data column, the only one that's independent of taking the daily average for continuous data. For 2022, we see much of the same. So again, the second to last column there, column K, a lot of instances where DO is less than 4 for a long time. Hypoxia, similar. We still have a number of sites that are returning large hypoxic events frequently. I want to call attention to a few things here. So first off, for 2022, the data is only current through the middle of September. The season is still going. I don't think these results are going to change much because when they fail by a lot. And so the addition of like an extra month of potentially good disassessment data, I don't think is going to be enough to bring the number up to where it would have needed to be. Again, we see that the biological metrics would suggest all of these areas should be relisted. And again, the 3 or 5B methods agree and return a similar result that all of these areas would be relisted. I think particularly encouraging, so the Rehoboth Bay Sailing Association is the second to last row. It shakes out as what I would call sort of medium impaired. So it's not nearly as impaired as the tributary sites, right? It still has these low DO events that last a long time, but much fewer than the tributary sites. And it actually has none of these long-term hypoxic events. So it's not as impaired according to those suites of metrics as the tributary sites. And yet the 3 or 5B method still flags it as being impaired. And so that's a little bit encouraging to me that maybe the 3 or 5B methods are adequately sensitive to picking up sort of these medium impaired sites, these less than horrible upper tributary locations. Oh, I will call, so coastal kayak, very brief data set, right? Only a couple months worth of data here, but it's coming back as supportive of the twilight. And that's encouraging just to see that there is an open water site that we are actively monitoring that doesn't come back as bad. So looking forward to seeing that in the future. And so my next steps for this are to, or our next steps for this are to begin to come up with some ways to compare years together that are biologically relevant or geochemically relevant. So some way to assess the severity of one year against another that actually means something for species that they care about. And I think Scott is going to present some of that work that he's been doing, some exploratory analysis that get those exact questions.
Time for a question?
Sure.
Just when we go back to when they devised the water quality standards many years ago, how was Ford chosen? And I think that you would have to say that there was a lot less data. We were relying on the RAG samples. So there's a lot of perhaps abundance of caution built into that standard before. You're not going to kill fish before, but people were understanding that there's this complexity, dynamic in the environment, and how things were bottoming out. So what this is implying that maybe water is a good standard. Is that some way to look at these things?
Yeah, so I have it on the summary slide after Scott's thing, but I think that's our next logical step, right? Is we have these data that say DO is really bad. But the next question from the public is, so what? What does it actually mean? What's the impact to crabs? What's the impact of summer flounder? What is the actual implication? And so I think we really need to start, that should be a priority for us, is getting at some type of biologically relevant threshold. What is the actual impact that affects the bioetic area? I have a feeling that we're not the only estuary that's curious about that. I would think that most sites in the Atlantic are asking that same question. And so I'm open if folks are aware of any from other areas that have looked at that question, or maybe someone online is familiar with an estuary that's looking at this particular issue.
So in terms of QAQC, are you satisfied that your sensor locations are representative of, or representative as possible as the entire breach? You guys do transects on incoming and outgoing through the tide cycle to understand?
Yeah, so we haven't. The bottom decks are pretty homogeneous in all these areas outside of the boating channels. So it's not that we're sampling in deep water, and the rest of the river might be checking for deeper.
Right, the flow could be different.
Sure, the sites are very shallow shoreline sites. I don't know coastal kayak. Where's coastal kayak?
Yeah, that's north of coastal kayak by quarter mile or something.
Is it a shoreline or is it in
if I would call it shoreline, it's not exactly shoreline. You can walk out through the 50 yards or something.
Yeah. The other one was in the channel.
Yeah,
it's on the channel markers.
All the stations are beginning similarly on that. There is fairly homogeneous cross section. Yeah, there is a.
But you don't do cross sections. What's that? You haven't done cross section.
No, doing the cross section would be a very expensive proposition. We haven't looked at partnering with construction bays and AUDs. What the cost of that is going to be.
Right, so that's a really critical element of the design.
Right, so, yeah, we can collect data for the next 25 years and still realize we missed something. So I'll talk about that a little bit as we get through this stage. So I thought I'd take a whack at this particular issue, causes of hypoxia, coastal lagoons. I realize I'm probably the 10th generation Cub Scout to kick this can. But I think it's an interesting topic to talk about. And a good way to segue into some of the modeling work that we're going to do. So causes of this is a high level look for 10,000 feet at what do we need to know and what do we need to do. We have these things that can cause hypoxia or no oxygen conditions in a coastal lagoon. And I won't read them to you. But we know here in the inland bays that the coastal ocean is not a source of hypoxic water. It's a fairly robust fresh water or high oxygen source. There's a monitoring station at Massey's Ditch just beside the inlet on the U.S. Geological Survey. They never had any issues with low DO or anything less than 4 to more than 6 hours, and definitely nothing less than 2 at any time. So our ocean water end number is very oxygen. Very, very healthy from that perspective. Does it have an organic load? Probably. Does it have a nutrient load? Yeah, it definitely has a phosphorus load. But it does not have a lot of the other things we see in the tributaries and in the open waters of the bays. We do know in the inland bays from work by Jeff Cornwell and others that the sediment has tremendous oxygen demand, both from organisms living on top, algae living on the sediment, and from geochemical reactions between sediment and the water column. Those things can consume oxygen, they can release or take up nutrients, a very important feature and process in the bays. We did the work to look at correlations with salinity and POPs. There's basically not a lot that we can see and hang our hat on for salinity and tides as in looking for an association with hypoxic or low DO conditions. Looking at the variability of turbidity and pigments, there's so much variability in those two constituents that you cannot see any simple population-wide associations between low DO and those things. We do know that we have to go back and look at specifically the pigment data a little more carefully to see if we can tease out some of the responses that might be dial. So what does our low DO look like? What are the characteristics of dissolved oxygen and hypoxia at our station? And here I'm looking at 5 stations, 2021 on your left, 2022 on the right. And when on the y-axis, I'm looking at consecutive hours of less than 2 milligrams per liter DO. And the stations, Delaware cultured seafood, Morton's Bluff, fisher stock, robin stock, coastal kayak. Coastal kayak is mostly an open water type of setting, and the line never goes above sea level. They never have any less than 2 events for more than 6 for consecutive hours. All the other stations do. And what's the cause of that? What's happened? Well, just from a gross level, we have some days where consecutive hours of hypoxia exceed 10. There are some periods of time where these hypoxic conditions exceed 1 day. But the way we count these, the counter resets to 0 every time. So there are some times when hypoxic conditions go from day to day. What's interesting is that all the stations behave similarly. When there's low DO at one station, all the other ones seem to do it, all the tributary stations. And there is some variability from year to year, which you would expect to find. And so now, one of the things we will be testing in the future is when we have signals like this, what other variables are responding to them besides dissolved oxygen? And what other things can happen as a result of these types of dissolved oxygen signals? And now, so stepping back, looking at some of the potential causes, okay, is low DO water coming from the watershed and into the tributaries? And so one of the things we have to work with here is a oxygen monitor at Millsboro Pond outlet or by the U.S. Geological Survey. That's been in place for several years. That's the pink line at the very bottom down here. What you'll notice there are a couple of excursions, very small ones, where we can get 4 to 5 hours of hypoxic conditions at Millsboro Pond. But important to recognize is that the other tributary stations in the bays do not respond. They respond at the same time as Millsboro Pond, but they respond much more frequently to hypoxic conditions in Millsboro Pond. To me, this says Millsboro Pond is not delivering, or any tributary for that matter, is not delivering enough low DO water to the estuary to create low DO conditions in the estuary. Shouldn't be a surprise, but it's good to know. In 2022, much the same story. So one of the other things that we've seen in the region, 1972 tropical storm Agnes dumped a tremendous amount of rainfall and sediment runoff into the Susquehanna, and then a few months later, I heard Chesapeake Bay had some serious hypoxic excursions that lasted for a long period of time. Important in that story is the delay between the delivery of the material and the response of the system. Right. So we'll look at it again here. The pink line, there is discharge from Millsboro Pond, measured by the U.S. Geological Survey, and then the DO signal, number of hours of DO less than 4 in this case. So one of the things I first noticed with this plot was, yeah, there's a clear association between storm runoff events and low dissolved oxygen in the estuary. But yeah, the tributaries are not delivering the low dissolved oxygen water. There's no time lag, and they happen simultaneously. And there are low DO events that occur without storm runoff. So there's still one more issue here that we cannot resolve from this picture, is that are the tributaries, the freshwater tributaries, delivering enough carbon to create low DO conditions later on? It is possible. The one that seems to answer a lot of the questions and check the boxes is it's solar energy or insolation. How much sunlight is happening? Is it a cloudy day or the sun? So what we find is a very clear association between cloudy days or rainy days and low DO conditions at our station, all of the stations that have low DO problems. And in this case, I'll point out that the insulation axis is on the right and it's reversed. So low insulation in the charts is noted by peaks in the pink line, right? Those are really bad, but they don't show up quite as well and don't show the association between cloudy days and low DO elements if I hadn't turned it around. So there's this clear thing here, and it's more than 90% of the low DO conditions are associated with cloudy. Should not be surprising. If there's cloudy day, there's not as much photosynthesis to drive up the oxygen content during the day before it crashes. In this case, I would tell you the solar energy signal is measured at Delaware. So it's in the watershed and not too far from 2 of our stations that was So the other big piece of dissolved oxygen in terms of physics of it is the temperature dependent on the solubility of oxygen and temperature.
Question. Does this have nighttime data extracted from? Are we looking at just solar energy in the daytime? Are we looking at nights and all the peaks are on nights because it's totally no post?
We're looking at a 24-hour signal, but of course, yeah, solar energy only happens in the daytime. So two things to remember about that is the length of the sunlight hours changes over the season. And I was going to get into this on this slide here. But yes, it kind of normalizes it that everything is only daytime values of sunlight. Nighttime is when plants start to respire and consume oxygen.
So all peaks, nights.
No, there are cloudy days when the amount of sunlight reaching the surface of the water was restricted by clouds.
Scott, you're using an integrated daily value probably for the day.
Yes.
Yes, so the one number represents the 24 hours of integrated irradiance, which all fell during the daylight hours.
Got it. Okay. Cool, thanks. So, yeah, higher temperatures, they're Henry's law, you can't have as much oxygen dissolved in the water. And so I thought this was a particularly telling graph, and this happened at all of our stations. The correlation might not have been as high here. 56% of the variability of dissolved oxygen can be related to variation in temperature. That's pretty remarkable. A couple things to point out here. When the temperature becomes greater than 9 degrees for extended periods of time, it seems to be a trigger for low DO events. We have low DO events when the water temperature is less than 9, but they don't last as long. And the water column tends to rebound after that happens. What I would point out to you here is that the greatest diurnal dissolved oxygen swings occur in the warmer water. So but what does that mean? In the summertime, we get dissolved oxygen saturations of in excess of 250%. That's a very large number. You can see 18 to 20 grams per liter. But then the following night, it's near zero. So think about that if you're talking about daily averages. Especially in the summertime, when we might have 14.5 hours of sunlight, and we have 14 in it, we'll have 12 hours or 13 hours of supersaturated oxygen. That has a tremendous impact on the daily mean calculation. So when I look at all these things, the frequency and magnitude of low geo conditions in our tributary stations, I think it's pretty clear that the water quality conditions are highly unsuitable for most aquatic animals that require oxygen. If you're a crab or a fish, and those conditions exist, you're going to flee. If you can't flee, you're going to die. If you are a benthic worm and you can somehow retreat into your burrow and weather the storm, you might do okay. But it's definitely the limit. What types of creatures can live on the bottom or in the water column in these areas? In another way of thinking about it, I call it loss of habitat. We've limited the habitat area where a lot of these species can survive. So thinking ahead here, I brought up one point. Is it appropriate to use a full year's worth of data to do geostatistics? I would say probably not. We should think about revisiting that and look at our most stressed periods of time as the key indicators for evaluating dissolved oxygen. The other piece of that is, should we be using daily mean dissolved oxygen data from continuous suns in the case where it's hypereutrophic conditions and dissolved oxygen can reach 250% saturation? I would say most likely not. So this is where I would give a lead in to how do we approach this issue? How do we potentially explain multiple variables with time variance driven and process and multiple internal feedback loops between the different processes that are happening? Thinking back to having Don Vitoro here for a staff meeting back in 2019 now. He said, if you can't explain it and clearly define how you're explaining it with a degree of confidence, you're just guessing. And for that, engineers love to make word quality simulators, hydrodynamic word quality simulators in this case. And I think that's really where the next step is for trying to understand what's happening, which processes are driving this. And then next, what can we do? What knowledge can we turn in the watershed or in our practices to help alleviate some of these conditions? Yeah, so
Scott, one more question. Is wind innovated anywhere? So the turbulence of the waves and the amount of oxygen it puts in them?
Wind data are available.
Not in any of the data set for Farley.
It hasn't been done. The DAX Pro station where we measure solar energy has wind, speed, and direction data available.
It has to be a major effect. I mean, it's the wind is driving the diffusion between the atmosphere and the water, so it has a huge effect. And it's also creating circulation patterns in the bay, so bottom water is coming up on the leeward side and the bay. So
yeah, it's really hairy and hurry. I've looked at this at Horsey Pond where we had a nice. There's just one direction of the pond. It's oriented east-west. When you look at the association of wind speed and direction when it dissolved oxygen events, and it quickly became a very difficult problem to solve. Too many guesses at the moment. But yeah,
one of the best measures of the wind speed is what the water surface is doing. I mean, but that's very qualitative. But you're not going to have anemometers all over the days, but you could really segment some of your analysis of whether you had white caps or quite small craft mornings, and anyway, it could be done in a very general sense. I think using marine predictions.
Yeah, I think what's really telling here in general is that all the tributary stations behave the same. And some of these stations have different orientations and they're different things. So the wind conditions in a tributary may not be as significant as they are in the open water because there's an fetch for the wind to drive water conditions. And that might be a key reason why the tributaries behave so poorly with respect to salt oxygen. They just don't get that mixing that in the water.
Cool. So I'm just we already touched on the first one here, just summary before we get through this, but I'm just looking to see in future years how some of our medium incident sites or how some of our more impaired sites compare to the 305B methods. I know that STAC had tossed around the idea about providing comments to the 305B methods when they solicit those comments. I would suggest that we consider incorporating some type of temporal restriction on the continuous data, especially for that first percentile. If we measure from January to the next January, that's a much different time period, and our first percentile is going to look much different than if we just talked about June, July, August. So some guardrails around those particular data sets would be very helpful. I already touched on this, but working towards establishing biologically or geochemically important thresholds. I'm open to anybody who's familiar with studies from other areas that have done this exact type of work, or if anybody's interested in collaborating on this. And then I will end with a pitch. So we're increasing, we have funding from the infrastructure funds, hopefully to increase from 6 stations to 9 for FY23. We've already chosen Love Creek and Whites Creek as 2 of those locations, but we do not have a 9th location decided yet for FY23 and going forward. So if you're looking to get a sonde in the water to help you out with a project, or you're familiar with any other researchers who are trying to get a sonde in the water to help out with a project, now would be the time to make the ask, and we can see if we can make it work. We want the data set to be used and useful to others, community at large. So if you're looking for something like this, contact myself or Zach. Thanks.
We have a question. Please remember to speak it loud and maybe like direct it towards the owl in the center for folks.
Might be
who
able to
might be
repeat
here.
it.
You can
Okay,
repeat
yeah,
it.
if you can't hear me, let me know. One thing that is interesting to me, okay, Robin, I wish Robin Tyler was here. Robin Tyler did some of the early sound work in the early 2000s, I guess, as far as PhD, and this is at a time when DENREC was kind of well funded with hysteria money and monitoring and anyway. So some of what was most dramatic to me at least was how dynamic these changes are across the period of minutes to hours, and changes throughout the course of the day. It's a very dynamic system, and so that's where you're really kind of blown away by it. And you lose some of that when you look at everything pulled together. Now, as far as I know, okay, the issue about delisting and listing in Upper Indian River, that's been a problem for a while. People have known that it's an optic and there's fish kills and stuff like that, but yet it doesn't get listed. Now, I think when Robin was doing, some of these arguments were the same when Robin was working at DENREC and he was seeing this, and I don't know how that was resolved in terms of the 305 report. Does anyone know how they resolved this incongruous nature of this data then?
I do not know.
Well, it's worth looking into, I think. And whether the other thing when you look at this long-term perspective, it's great. I think it's wonderful that you have this opportunity to continue this for another year. But then what happens when the money goes dry? Because it will go dry eventually, or maybe you will think that, oh, we have enough data this way, and we can model everything. We don't need this anymore. But how are people going to judge change over a 20, 30-year period when 5 years at a time you're throwing in this new kind of perspective, and then you're taking it away and you're putting it back in, you're going to get these delistings and listings. I mean, that should.
Yeah, so we're hopeful that this network stays in place. So the infrastructure funds are being used as a stopgap because Project Wicked is coming to an end. We're in discussions with some folks at DENREC to try to get financial support for all or part of this because we want to see this network. We invest a lot of money into getting this in the ground and a lot of man hours getting this in the ground. So we'd like to keep this up and running for the indefinite future.
Okay, well, that's good to know. Now, and I don't want to keep talking too much, but I do have some issues about, okay, we have two boundary layers in the water column. We have the boundary layer at the surface with really dramatic differences in oxygen dynamics in the region, and you have that boundary layer at the bottom where all these biological and chemical reactions are going on. So most of the typical surface water graphs are really kind of near that upper boundary layer, best case scenario. And then when you're sticking your data sons near the bottom, pretty much keep them underwater, you're getting a worst case scenario. So, and I think Mark was implying that we have to do some of these kind of transects to kind of figure out what some where you are in that boundary layer. And if you're in a protected cove or something like that, that boundary layer could be huge. And if you're in an open water area, it's not. And so there's probably some, I would almost just say that there may be an effect of, the use of that dock that is being, where the sound is being either the use or the position. So what are the solutions to these? Now, South Bethany went into the, I don't know, I'll bring up briefly another sort of wealth of knowledge of South Bethany that's kind of disappearing. But they played around with these water quality signs for 5, 6 years, and I looked at a fair amount of data. Now, this was in a very controlled environment. They're looking at these canal systems. They have in one case they were aerating one and not, and then they were having sound in each, and then they were doing some other things, looking at taking 2 handheld meters and doing transects at the bottom and the top, and I don't want to go into too much, but they spent a whole lot of time and they really weren't clear answers. And it seemed that some of the answers really depended on how you make the measurements.
Yeah.
You know,
Yeah, I don't disagree. I would say the 3 or 5B methods, as far as I can read into them, don't make a distinction between where the dissolved oxygen conditions are for. It's a simple impaired or not impaired. And so previously the graph samples were taken surface or just below surface. They're obviously not capturing the worst possible conditions, and the metric is not necessarily to paint the rosiest picture of the location. The metrics that we're using, or the sampling methods that we're using, are to directly assess what's the worst possible dissolved oxygen condition at this area, because that's the determination. It's not if the surface waters are impaired. It's if any of the water in that segment is impaired, it gets impaired. And then I would also bring it back to the biota that we're curious about. So most of the species that folks would be interested in would be benthic associated, the exception of many would be benthic associated critters. So summer flounder, blue crab are benthic, croaker, spot, and that's 2 most common species up there that people would care about, also benthic. So grabbing that data from the bottom feels appropriate to what the biota average to do. You must.
I agree too, except obviously the closer you get to that bottom, any day of the year, you're going to hit 0 when you get about a centimeter from that muddy bottom.
Yeah, so these
I
days.
mean, that's just my experience.
Sure.
It happens really quick.
Yeah, so we have a standardized 6 inches in some sites and a little bit more than that in other sites, but we have a standardized number to hit per location, so that we're at least we're trying to avoid exactly what you're talking about, that bottom 1.5 centimeters of water, or whatever. That's just consistently terrible because of all the anaerobic things that are going on down there and all the different oxygen demand.
Is there any possibility in looking to the future that maybe you would combine a floating surface on with your bottom sites?
Yeah, that's an option.
At least then you get the best and worst case scenario.
Sure.
If you want to clarify.
Yeah, that's definitely an option. And as we start to get more of this equipment, we have more free stuff to play with like that. You know, more songs that are in the lab, they're not being used at that exact moment in time.
Yeah.
And so then we can start to ask questions.
I thought that Scott had water pressure as a variable, so he knew where his song was versus the surface of the water all the time. Did you not do that, Scott?
Yeah, all the songs have a water pressure sensor built in, so we're measuring tide at all times. And so we know the depth of submergence.
We know how far it is from the surface all the time. I don't know if we tried to make a correlation there.
Yeah.
Well, you know, here's a silly kind of example of something that went on the South Africa when they were doing transect to the canals with the these were handheld meters, 6 inches from the bottom and at the top, and they could do the transecting in the canal, got aerated and not aerated. And they kind of gave up on it because what happened was that the average of the 2 readings was you'd actually see a decrease in the canal that was mixed. So it was kind of implying that this process of aeration was having an exact opposite effect than what you intended. Okay, so the canal that had aerators every 100 feet along there was the average of the top and bottom readings were actually lower. So my interpretation is that you were oxygenating the benthos and you were getting decomposition and you were getting the consumption of oxygen. That's what you were doing by aerating. You were mixing rather than delivering oxygen, you were just mixing and you were delivering oxygen to the sediment, if you will. Anyway, so there's a whole lot of very puzzling things that go on these micro scales, and that's anyway. I'm just sort of from my experience of looking at these things, it's just words of caution to try to look at the whole picture.
Do you have a question or comment or suggestion about location?
Yeah, for the, you mentioned these issues about floating sound or something, you have a location up the ramps, maybe that's an option for that.
Yeah.
And one more question too about, does anyone know how deep the Massey's Landing Pond is? Massey's ditch there is quite deep, and I doubt the pond is very, very deep. I bet it's feet away from the bed coast rather than inches.
That's true. Plus, it's very well mixed there.
Yeah.
Just one question for me. When is the time period for providing comments to DENREC about their technology?
I checked the website, I think a week or two ago, and I didn't see anything was there yet. I was hoping somebody would be on the call, but I don't know.
I don't see Bono. I don't know if Mike or Steve. I see them in there. Lori, if any of them are aware of that time frame. Not a meeting. Maybe that's something we can follow up with the email, just so we don't miss that opportunity, because I think you've got some really good data here and your recommendations make sense to me. So I think it's worth discussing and trying to institutionalize some of what we're learning. Yeah. For sure.
Casey Robbins, as a proud customer of Robbins stock, I just want to point out the variabilities here. The water depth during item was probably more than 6, almost 7 feet. There are times when the water depth on that sand is way less, or the water depth at the location is way less than 6 inches, 2 inches. So sometimes that sand is in one boundary layer, sometimes it's in the other, and once in a while it's in between. I don't know exactly how far off the bottom that one is, Zach, but clearly it's susceptible to some peculiarities. It's also in a slightly bay-like formation as the Guinea Creek winds through there. And there's a certain amount of, I'm sure there's a certain amount of swirl in the flow. And Guinea Creek, like all of our cribs, we've known for decades, centuries, that this whole system is a very slow flushing system. It takes a very long time for a given drop of water to come off the freshwater feed and make its way out to the ocean. That's an extremely long time. So this stuff moves back and forth constantly.
Thank you, Andrew. Thank you, Scott. We're going to go ahead and move on to our next presentation. And after that, we'll take a short break. And so I know folks online, you have the flexibility of giving yourself a bathroom break whenever you need it, but we'll have to remember to do that for those of us in the room. So we're going to go back to our original first speaker, Dr. Matt Parker, who is with the University of Maryland Extension Program. He's going to share with us some of his work that he has been doing with a colleague from NOAA about developing oyster nutrient trading in Maryland, and will it ever pay off? So I know we've got some oyster growers in the room, and it's an interesting area that's developing here in the Inland Bays. So we're eager to learn about your work, Dr. Parker.
All right, thank you very much. Sorry, I had a family issue to take care of this morning, so I was a little bit delayed. Let me share my screen here. Once I figure out the right screen to share.
You weren't here, but we went through the same thing.
All right. Okay, let me know when you can see it.
Yep, we can.
All righty, so thank you again. My name is Matt Parker. I'm an aquaculture business specialist with University of Maryland Extension. And for the last, I don't know, seems like forever years, I've been sitting on the EPA best management practice for oysters to come up with ways to get some nutrient credits in Maryland from oysters. So I was asked to give this presentation to talk about what's been going on with regards to oyster nutrient trading in Maryland and a status update on what's going on. So here we go. So if you were to want to establish a best management practice there's quite a long process. Some group has to ask EPA for permission to form a panel to look at the topic. And then they have to submit all the panel members to the EPA to make sure EPA says, yeah, these people know what they're talking about. And then you have a bunch of meetings, and then you do a bunch of research, and then you obtain group consensus. It's not majority, it's consensus. If one person says no, then it doesn't go forward. Then you write up all your results and reports. You have to present the report publicly. In this case, we did it to the couple of the goal implementation teams for the Chesapeake Bay office. And then you have public comments. So you have to address those comments. Then you resubmit, and then the agency either votes to approve it or disapprove it. And then once that happens, the BMP is created only for what is in the items in the report. And then it's up to the municipalities or whoever to figure out if there's going to be any compensation at all. So the BMP expert panel just comes up with the number as far as how much nitrogen or phosphorus is in the oyster or whatever BMP practice you're looking at. And then someone else has to figure out how to implement it. So we established the oyster BMP for the Chesapeake Bay, and do this a nonprofit group, Oyster Recovery Partnership, in April 2015, asked to form an expert panel. And we had our first panel meeting in September of 2015. So our panel charges were to identify and define oyster practices that could be considered a best management practice. Develop a pollutant removal crediting decision framework on how that was going to be, how we were going to do this. And then come up with nitrogen and phosphorus removal estimates for oyster practices that we deemed had enough scientific support. So the projected project end date was August 2016, but things took much longer than expected. We actually just had a meeting last week. So it's been going on almost 7 years. So this is a slow process. Granted, we had a issue with COVID and it kind of threw things into work, but we did a lot of electronic things. And still, it took a long time when you've got 10 or 12 people and you have to reach consensus and everybody is an expert. Sometimes that leads to interesting discussions that take a lot of time and making sure things are exactly correct. So we had 16 members. And like I said, it took a while to reach consensus. The panel did a literature review for all the available science. We looked for any papers dealing with oysters and nutrients to try to extract information. We looked at reports. We looked at unpublished research data. We evaluated the information to make sure it was appropriate. We talked about nearly every single paper and what was in it, and there was hundreds of papers. And then we had our expert panel did an analysis of all the data we could find. So like I said, it takes a long time, as you can imagine. So this is the table from the report of all the potential practices that could generate be a best management practice for oysters in the Chesapeake Bay. We talked about private oyster aquaculture, and if it was hatchery produced diploid or triploid oysters or wild set. And then if it was on grown on the bottom or a gear or moving oysters around, or you just put substrate down. So it turns into quite a large undertaking to evaluate all the different scenarios. We looked at the public fishery on whether or not it was a hatchery supported public fishery or if it was a naturally supported public fishery. And we were supposed to look at oyster reef restorations on whether it was using hatchery produced oysters or wild set oysters and the different things that go with that. So furthermore, we had to come up with a report. So the things in orange, we're like, we can knock that out and do that fairly quick in the first report, which that's the one that came out in 2016, I guess. And then the ones in gray said, oh, that would probably be good to do in the second report because we need a little bit more information and don't have what we have to do it right now. And then the ones in yellow are, these all sound great, but we just don't have any information available to evaluate to say whether it would be good or not, or to come up with a number that we could scientifically defend. Oops. So we took the tissue from aquaculture oysters, since it was the low hanging fruit and one of the easiest to verify what's coming out of the water. So like I said, we looked at all the studies available for oysters from the Chesapeake Bay. We even looked at studies available for oysters in the other areas of the country. We looked at published data, unpublished research reports. We looked at triploid versus diploid oysters, and they plotted the values of the dry weight of tissue shell and in the height. So everybody harvests in whole animals, but we had to figure out, all right, if an animal is 3 inches, how much tissue is in it, how much is the dry tissue in it, to get the true amount of nitrogen and phosphorus. And then there was concern that maybe we would overcredit because there's some wiggle room in our numbers. So they did a quantile regression. Julie Rose up at the Milford Lab did this for us to minimize any areas. And we took a more conservative number just to make sure there's no overcrediting of the nutrient reductions from aquaculture oysters. So as I mentioned, our first report, we submitted it in September 2016. It was approved in December 2016, and it included recommendations for nitrogen and phosphorus removal from aquaculture oyster tissue. We delivered a report by our original deadline that we had set out, but it still left 86 scenarios that we didn't get time to figure out. That takes a lot of time. So I've got a table here of the default estimates for the amount of the grams of nitrogen and phosphorus in diploid and triploid oysters based on size. But that, it's kind of hard to, I have 5.05 grams of oysters and of nitrogen in a 2-inch oyster. That's really hard for a stakeholder to kind of wrap their brains around. So they came up with a slightly easier to read chart. So if you harvested 1 million oysters, how many pounds of nitrogen and phosphorus would that be? And we broke it down by size classes for diploid and triploid oysters. And then if you think that the way that worked is there was a default value of 3-inch because that's the public harvest legal size. If you wanted to take some extra time and sample your oysters and keep better records, then you could get a credit for a larger, or you could break it down into these different size categories based on what your oyster sizes were that you were harvesting. So since December 2016, we have been busy, but we've been slow. And we've been looking at all the other scenarios: nitrogen, phosphorus in shell, denitrification, sedimentation, things in the public fishery, restoration. And as I mentioned last week, we had a report or had a meeting last week that pretty much finalized our second report. The first one, was like, it was like a rocket ship. This one was more like a snail. And that should be going out after some tidying up in the next month or so for public comment to look at. So now, what about compensation? As I mentioned, the expert panel only determines the nutrient reduction rates. We were like, all right, if you want to use it, this is the number. The county, the city, the state, whoever manages nutrients in your water body, they will determine if and how compensation will be implemented. They might just say, thank you for all your extra nitrogen and not do anything about it, which I would like to see some compensation, but it's up to that individual municipality. The state of Maryland decided to include oyster aquaculture into their water quality trading program. So there is the opportunity for compensation from currently for oyster aquaculture oyster tissue. So far, we've had 2 trades. And it took a while. So we had one from the voluntary market. So this is, you just feel good, kind of like when you go buy an airplane ticket, if they ask you if you want to pay more for your airplane ticket to offset the carbon that they're going to use. Same kind of thing. So the Baltimore Convention Center purchased 4 nitrogen credits in May of 2020 for $1,600, so $400 a credit. And I think that was brokered through a group called Blue Oyster Environmental, I believe, and it was from a farm in the Chester River. And our second trade was through the regulatory market. This is where the municipality was looking to offset something that they had done. In this case, Anne Arundel County, which is where Annapolis is, purchased 107 pounds of nitrogen and 12 pounds of phosphorus for $4,950 to offset runoff from a parking lot or something that they put in or they needed to deal with. I don't have what the amount was for the nitrogen and what it was for the phosphorus to determine like an average price or anything, but that's the only 2 trades we have had. We have tons of oyster credits available online to be purchased, but nobody's buying. So it's like this is not Field of Dreams, make it and they will come and buy it. You know, it's not an iPhone. You know, it's a limited issue. There are issues with, you know, if I generate a credit in the Chester River, I can't buy a credit from the Chester River to use in the Potomac River. So there's issues with watersheds and what's available where and who's in the area. And honestly, if you're growing oysters, you're probably not growing them in areas that are horribly polluted or that need lots of credit for these other places to offset what they're putting in the water. You know, you don't want to grow oysters in bad water for human consumption. But last month, there was a little bit of a light at the end of the tunnel. The Maryland Department of Environment was tasked with implementing the Clean Water Commerce Account for environmental outcomes. They got like $20 million per year for the next 10 to 20 years to purchase nitrogen credits. And in that was offset $7 million per year to purchase nitrogen credits from agriculture, which is where the oyster BMP or the oyster credits fall. I know that several oyster farms applied for this program. It was kind of a lengthy application form where you wrote how much you wanted for your nitrogen credits and how many you'd be able to supply every year and how many years you'd be able to supply them. And then Department of Environment would decide who they would buy from and how much they would buy. The deadline was September 9th, and I have not heard if they've made any decisions or heard of anyone getting paid from that. So that's the closest thing we've got to a trade that might happen anytime soon. So nutrient credit trading is a fantastic idea on paper, but it is very hard to get it implemented successfully when it comes to oysters from what we've seen here in Maryland. Like, we've got it, we can do it, but it just hasn't been as popular as we had hoped. So with that, I will be glad to answer any questions you guys might have on what's going on with Maryland with oyster credits and what we're doing and what's going on and what might be coming up.
Thank you, Matt. You know, we're in the, we don't have a formal nutrient trading program here in Delaware. That's something back when I worked at Denver talked about. Jen Walls, who's was on, I'm not sure if she still is. It's something she had been looking at for a number of years. So we're in a place where it's, I don't know if it could or would happen. I see we have a hand raised. Alex. Yeah, Alex, we're not hearing you yet. But maybe it was an accidental hand raise. But you're up next, so we gotta make sure we have technical difficulty. Let's figure that out so we can, after a little bathroom break, we can get you live and speaking.
He might be, looks like he's muted.
You hopefully can get, maybe he's getting connected to a speaker. So
I would also add that if Delaware wanted to come up with this, I bet you could just use all the work we already did in the Chesapeake Bay for oysters, as far as the nutrient numbers, to help speed that process up.
yeah.
I would imagine that it would be fairly similar, pretty close, that you might be able to petition EPA or whoever to just use those numbers and save you a ton of time.
So I think we've got a question in the room. Aging.
Did you accumulate the cost of your studies? What did it cost you to go from zero to now?
I don't know, but I bet it's super expensive if you think of every 16 people that were on the panel and their time that they put into it. And then if you want to, like, I submitted them data that we hadn't had published at the time. It's been published since. But if you want to look at the cost of doing all that, I imagine it is quite expensive. But, you know, I would say this is kind of a labor of love. We didn't get paid anything extra to do it. We didn't bring in any grant money or anything like that. So no, we did not come up with a cost to develop this BMP.
Well, I'm sure everybody in this room appreciates your effort.
Yeah, definitely. Chris.
Matt, I was wondering about the discounting that you did. Is it easy to reverse engineer that in the report? How much you might have dialed down credit in light of, you know, model guidance and trading program guidance to figure out maybe?
Yeah, if you go and download and review the report, it's in there in much more detail on exactly what we did and how we did it, that you'd be able, and there's appendices galore that you could go look at and search through it to figure out, all right, we don't want to use that same number. We're going to beef it up. And then I think we use like the 50% quantile when they did it. I am not fluent in quantile regression. I've never done it, so I don't know exactly how to do it, but I imagine you could figure it out pretty well. And like I said, Julie Rose at the Milford Lab, she's the one that did that analysis for us, and I'm sure she'd be glad to explain it if you had any questions.
Thank you.
So Alex, let's see if we can get your audio to work the same. Give you a count of 3, and then we're gonna go to another question in the room. There you go. Allison.
Hey, Matt, thank you. That was really interesting. And I do think that Delaware could use a BMP similar to this. I think it could apply to restoration projects. So my question is, your nutrient reductions, your table is done by size class. Do you have to, when you're in the field and you're looking at the oysters, do you have to remove them to get their full length? Is that something that you can do while they're on, like, in place?
Well, the current BMP that we have approved is for aquaculture oysters only. So those are harvested, and the way that it's set up in Maryland is you can take the default estimate, which is the 3-inch estimate, and that's fine. You just say, all right, I'm going to take the default and be happy with it.
Okay.
If you want, they have a way set up that if you want to space it out and get, like, I got 100 oysters in the 2-inch, I got 300 in the 3-inch, and I got 200 in the 4-inch. If you keep good records, they just ask that you sample your oysters that you harvest. I believe it is twice a year that you sample, and you pull out 10 bushels worth and count and how many of what size are in 10 bushels and submit that paperwork. So that's how they've done it, that if you wanted to break it down into those different size classes here in Maryland. Or like that company I mentioned, Blue Oyster Environmental, you can pay them and they'll do all that counting, and I'll do all the paperwork and everything for you, but they take some percentage of any sale that you might get for that or charge a fee for that. And I don't know what that fee currently is. And it may vary between growers based on what they do. Now, for the restoration, that should be in the upcoming report. And there is some annual estimation of biomass that you have to do on some or annual or biannual, something like that. I don't remember exactly which one it is, to go out and submit every year to get credit for the biomass that's increased on the reef in that last year. So there is a sampling protocol that's spelled out or suggested in the next report that will be coming out.
All right, thank you.
So I'll just point out for folks in the room, I know the chat is up there, but it's probably small for you, but Jen Walls did put in the chat that Denmark has been slowly working to establish an offset and trading program for nutrients. There are many challenges, as Dr. Parker indicated, and she would be happy to share them with us at a future date if we're interested in learning about that. So the efforts that they've had. And Mary Ann also put in the chat the link to, I guess it's the first report, correct? Yeah, first report.
Yeah.
So we'll make sure to include that in our meeting notes that for everybody, if you can't click the link right now. And Alex, who we've got to get his audio fixed, he did add his question to chat. And he asks, MGA has been involved with advertising Maryland's aquaculture. Have they been involved in advertising this nutrient trading program?
Well, the nutrient trading program is administered by the Maryland Department of the Environment. So I think they're probably the ones that would make any note that it's been going on. And then like the group Blue Oyster Environmental, I don't know if you guys have probably heard of him, Johnny Shockley. He never seems to be at a loss for words. So I'm sure that he's been promoting it as much as he can, because he's trying to make a business out of it. And then we've told people we put out there, but I don't think really there's been any trades going on. Maryland's first nutrient trading.
There needs to be a demand for buying it. You know, they have the pressure to reduce their nutrients by some mechanism that they either do it on site or that they buy the credit. And so.
Yeah, so Maryland Department of Ag, they started the nutrient trading program for agriculture back in like 2009, 2010. And never made any trades. And what I heard happen was everybody expected to be making these trades to like wastewater treatment plants and those types of places. But I heard that, because I didn't start till 2011, that Governor O'Malley gave all the wastewater treatment plants money to upgrade their system. So it kind of wiped out all the market that everybody happened. And then nothing happened for a long time. It got moved over to Maryland Department of Environment. We got oysters approved, and you can go on the Maryland Department of Environment page and see the list of all of the credits that are available and all the sales. And there's just like nothing happening. There's credits being generated year after year, but there's not like a ton of sales happening in any of the industries that are generating credits. So like you said, unless there's some other mechanism, maybe if they lowered the TMDL or something like that, it might generate more sales, but that's way above my pay grade. And I don't think I can't have anybody say, oh, Matt's saying they need to lower the TMDL, you know, that's just, or you know.
Well, that doesn't happen overnight either. You saw how long it took to get your report approved.
Yeah.
I was involved with the original TMDL process. It takes some time to come to those agreements too.
But to Alex's question, you know, that might be a good idea to try to advertise more towards these voluntary markets, like the Baltimore Convention Center, like, oh, you're coming in. Do you want to buy, just like the airlines do carbon credits? Do you want to buy nitrogen credits to help the Bay as part of your package program? You know, that type of thing.
Or a show of goodwill that you're a steward.
Correct. Especially for like environmental programs. Oh, you're doing a big environmental conference. Why don't you buy some nitrogen credits to help us out in the Bay? You know, that type of thing.
Ed, did you have a question?
Yeah, I was just curious if there was interest among other fisheries, crab or commercial fishermen in trying to get this kind of program for non-oyster aquaculture.
Well, one of the practices we looked at was oysters from the public fishery that are harvested from the public fishery. But the public fishery is owned by the state. You know, aquaculture oysters are owned by the farm. So that presents a problem with like who gets the credit. And the Chesapeake Bay model already has public oyster harvest, I think, in the model. So it's not something new, but I think we might have put something in there on how much it would be, but it would be up to the state to figure out how they would want to credit it or implement it as well. As far as other fisheries and things, maybe macroalgae or something like that might be good, which we don't grow them here in Maryland. Because they remove nutrients and carbon from the water, or it might be good for other areas. But when it comes to the public resource, I think it might be a little bit more difficult to generate any sort of compensation for the private person that's working that resource.
One last question from Chris.
Matt, I saw on your matrix regarding the reports and things that were on hold, you had mentioned enhanced nutrient burial. Is that something where the panel ran into an issue where they were more data limited or concerns about an argument like juice worth the squeeze?
That came up in our meeting last week. Larry Sanford is on the committee and he was like, I was brought in for burial and sedimentation. And we're like, we talked about this 5 years ago, Larry. We don't have any information that we could use to justify a number. So it's data limited. If there was a lot more data, then we'd have a number, but we don't have a number or enough data to look at it.
Okay, thank you.
Well, Matt, thank you. Really interesting. Would you mind if you can remember when your second report gets released? If you could share that with us, I think several folks would be interested in reading that.
Sure. Like I said, we had a meeting last week. There's a few items we need to tidy up in it and verify all the references, go to the right reference, all that kind of fun stuff that the young lady over at Oyster Recovery Partnership is doing. But hopefully within a month or so, it'd be good to go and sent out for public comment.
Awesome,
Jeff
great.
Cornwell over at Horn Point Lab is the one that's the chair of the committee. So.
Great, thank you so much. We really appreciate your time today, and we'll go ahead and why don't we take a 5 or so minute break for folks in the room, and Alex, hopefully we can get your audio working and then we'll reconvene. So thanks for joining us, Matt.
No problem. If anybody comes up with a question later, just shoot me an email. I'll be glad to try to answer it.
Great, thank you.
Hey, Jen, this is Alex. Can you hear me?
We can hear you, yeah. Good, we got you fixed.
And hello, Jen. This is Mike too. I had audio issues earlier. For some reason, I had to restart my whole system and come back in when you were asking about the DNREC question. But just in case I missed anything as a follow-up, we'll get that information for you, and then we can either email it to you or somebody regarding the comments for the 305B.
Perfect, thank you, Mike.
Yep, sorry again about that.
That's okay. Okay. I think are we unmuted?
You are now unmuted.
Okay.
There you go.
All right, everybody online, I was just yelling at people in the room to sit down. So, we're gonna go ahead and reconvene. I was saying we have 2 talks left and only about 68 minutes left to go. So, Megan's taking down our 5-minute break sign, and Alex, we're gonna turn things over to you. We invited Alex to come in. One of the things Mary Ann did before she left was she passed along information that she saw. Alex can talk about some of the water quality monitoring work that he had been involved with. Again, a Chesapeake Bay presentation, but along the eastern shore. And we thought some of the trends that they were seeing there probably have some relevance to the Inland Bays watershed. So we wanted to hear from him. And it's great that we have, we had that other presentation earlier today talking about actual water quality monitoring of our bays in Delaware. So it's really a water quality themed day, and let's see what we can glean from these efforts in the Chesapeake. So Alex, go ahead and take it away.
Thank you for having me. A short introduction. My name is Alex Soroka. I'm a physical scientist with the USGS based out of Baltimore, Maryland. And I used to live in Delaware, went to UD and worked in Dover for a while before transferring over to Maryland. And as you know, Jen said, this is a talk about the Eastern Shore, and you may be looking at this map and saying, well, you're looking too far to the left there. We're in the center for the Inland Bays. But I think that some of the trends that we're seeing in these Eastern Shore non-tidal watersheds, the landscape experiences the same agroeconomic system that some of the Delaware Inland Bays watershed experiences. And through the course of this talk, I'll try to point out some differences in between watershed characteristics and how things may differ between what I'll present here and what you may see in the Delaware Inland Bays. And so, press this button. Great, and it's a little difficult to hear. I was calling in on the phone earlier because I have better audio to hear you with that way, but apparently I can't talk through my phone to the meeting. So please shout out or put something in the chat. I can see the chat on the side. And so the objective of this talk was to give you an idea of how we conduct our load and trend calculations in the Chesapeake Bay watershed at our non-tidal stations. Take a look at some of these Eastern Shore stations and examine some recent and long-term trends in sediment, phosphorus, and nitrogen. And then finally, we'll look at some possible management impacts and factors which may be affecting these trends. So the first thing I'd like to point out, and this is much larger watershed than the Delaware Inland Bays watershed. And we have a series of monitoring stations throughout it. There's a 123 station network. And each of these stations has a gauge on it that's measuring discharge. And that's one of the differences in between the non-tidal network and the Delaware Inland Bays is that you have to worry, I believe, about water moving in both directions. It's not just going in one direction. This is a non-tidal network. And so at each of these stations, it's either the USGS or one of our partnering agencies from the state that is collecting water quality data. And we use these water quality data to estimate whether or not certain constituents are going up or down. And we use a process called flow normalization. Because the amount of discharge in a river has a strong, is a driving force in how many nutrients are moved, we remove the effective flow through a flow normalization process. And so this means that if one year you have an active hurricane season, it will lessen that impact on the trend that you're seeing through time. And so at these different stations, we collect water quality samples. It's over 2,400 samples collected annually from a variety of partners. And at these stations, if they have 5 to 9 years of data, we'll calculate a load at these stations. And then if there are 10 years or more, we can calculate a load and a trend. And the trend is from the beginning year to the end year, what is the likelihood that the pattern that we're seeing, if we're seeing a decrease, what is the likelihood that that is true? When we collect these samples for water quality constituents, we do a form of sampling called isokinetic sampling. This is different from a grab sample. An isokinetic sample, we tend to use this instrument on the bottom left of the slide here. It's called a DH81. There's different versions for different types of flow, but essentially the nozzle on the front of it will collect the same amount of water no matter what pressure it's under. So if you've got a fast moving stream or a slow moving stream, it will take in the same amount of water. And what this lets you do is as you go across your river, taking cross sections and you lower it through the water column, you're getting an even and representative sample. The combination of these results allows us to work our data up into larger models, which help us explain things in unmonitored reaches. This is important because monitoring is expensive and you can't do it everywhere. And so by relating our water quality that we measure in our streams to landscape processes and landscape factors, we get estimations of what is happening across the landscape. And that is what this figure shows. This is from spatially referenced regression models where we input monitored data and we use different landscape factors such as soil type, a nutrient input, for example, to estimate the amount of nutrition that's coming out to our surface water. What you'll notice here is that we've got two different areas that are so darker colors here mean more transport, and this is a map of nitrogen, and phosphorus looks relatively similar. Areas that have either high urban population, so you can see Washington, D.C. sticks out, Baltimore sticks out, or areas with high agriculture are also highlighted. So that would be the Eastern Shore as well as Lancaster County and some of the valleys in Virginia. The Eastern Shore in particular has relatively high nutrient input and transport factors, which lead to high nutrient movement from the landscape to the bay as a whole. So when compared to the entire bay watershed, a given acre of the Eastern Shore has a higher nutrient delivery than an acre of the rest of the Chesapeake Bay watershed. And that's because we're highly productive areas. As you well know, the Delmarva is the home to a large poultry production industry. And because of that, we have a lot of grain that goes to feed the poultry industry. And it may be hard to believe that on a historical basis, grain production in Maryland and Delaware is actually insufficient to meet the needs of the poultry industry. We continue to import grain from the Western United States. The grain that we produce is predominantly corn, soybean, sorghum, and also wheat crops, primarily grown as winter wheat, and they require nutrient input. Thus, the nutrients that we're seeing on the Eastern Shore for nitrogen and phosphorus are largely from agricultural areas. We don't have a large urban signature in our non-tidal stations. And I believe that relative to their area, the Delaware Inland Bays, of course, has a greater urbanized signature and has more of an influence of both wastewater and septic systems. And so how have nitrogen and phosphorus loads changed throughout the entire Chesapeake Bay watershed? Here we have these triangles. Green triangle down means improving trend or the load is decreasing. Orange triangle up means degrading trend and the load is increasing. Between 2009 and 2018, roughly 40% of stations showed a degrading trend. Roughly 40% of stations showed an improving trend where there's no trend at around 20% of the stations. Phosphorus is relatively similar, with 40% improving, about 30% degrading, and about 25% showing no trend. When we highlight the Eastern Shore, we notice that most of the stations have degrading trends, both for nitrogen and for phosphorus. Tuckahoe is actually showing an improvement for total nitrogen. We'll get into there in a second. The non-tidal stations, here we have them shown against an aquifer thickness map published by Denver and Nardi in 2016, show the surficial aquifer underlying the different watersheds. And this gives us some insight into both the travel time as well as possible processes that will impact the movement of nutrients. Nitrogen, for example, is conservative. It stays in the water column if there is sufficient oxygen. When oxygen is lowered, bacteria will start to consume the nitrogen, of course, in the denitrification process. You'll see in the upper chop tank, there's a relatively shallow surficial aquifer, and they also have hydric soils that are poorly drained. And so concentrations of nitrogen in the chop tank are relatively low compared to these other watersheds. The Nanticoke has a deeper surficial aquifer at relatively longer transit times. So let's take a look at sediment. Since 1985, sediment has seen an overall decrease at these 4 non-tidal stations, and has seen a relative decrease. And the yields of sediment per area are relatively low, and that's because of flat topography, shallow slopes, and relatively quick infiltration processes. On average, since 2009, sediment loads have increased at each of these stations by about 30% on average. And there are different ideas on why this is happening. And I wanted to take a moment and highlight some work done by our colleagues on sediment transport. And it's something that at the Center for Inland Bays, you may want to look at further. Greg Noe and others led a sediment synthesis, which reviewed sediment sources, transport, delivery to the Chesapeake Bay to help us understand how sediment is changing and moving. I think this is a fantastic resource, and I'm going to drop it in the chat. And there's much more where that came from, including a white paper. I would go and take a look at this. A lot of information there about, historical sediment transport from the 1500s up until today, and large changes in the landscape and how those have impacted transport. They also go into practices on the landscape which may be impacting the Delaware Inland Bays. For example, urbanization, disturbance of soil will lead to increased sediment yields. They also go into factors for movement in agricultural areas, and displaying once again results from a Sparrow model, the spatially referenced regression, this one related to sediment, where they look at the movement of sediment. And it's of course what is on your landscape that'll determine what's moving it. In the stacked bar chart, we see the percent of total sediment flux, and then they've got a number for the total flux on the right side. And what I'd like you to look at are these bottom 2 bars here. That's the Patuxent River and the Choptank River. The Patuxent has a more urbanized signature, and so urban development has a stronger impact on sediment transport than does the Choptank River, which has much less impervious cover on it. Agriculture is widespread and contributes roughly 70% of suspended sediment to the Chesapeake Bay. And part of the reason, and one of the reasons that we should be thinking about sediment, we heard one of the earlier speakers talking about sediment movement and its reactions in the water column, is that it has an ability to carry nutrients with it. Within the Chesapeake Bay, roughly 80% of the phosphorus is transported related to sediment, and roughly 20% of the nitrogen is transported related to sediment. However, when you look at what is happening within streams, they find that concentrations of phosphorus are lower than agricultural fields, but higher than bank sediments. And there are mixing processes and chemical reactions which are occurring. So we've talked about phosphorus, we've talked about sediment, and this leads us to phosphorus. And so in the short term, we're seeing strong increases in both total phosphorus and dissolved phosphorus at most of our non-tidal stations. All the Delmarva sites have degrading total phosphorus, and all but one, the Nanticoke, has degrading orthophosphorus concentrations. Excuse me. And so total phosphorus loads have increased by about 40% on average, whereas sites with degrading orthophosphorus have shown a flow normalized load increase of about 80% over the past, since from 2009 to 2018. Factors which lead to greater phosphorus transport, and some of this may be review, but as we've discussed, phosphorus binds to sediment and is primarily transported through sediment mobilization. Now, if your sediment happens to be high in phosphorus, let's say that you have been applying manure consistently through time. So much like the Delmarva Peninsula, we've had an active poultry industry here since the 1930s, and we've used poultry manure or poultry litter as a soil amendment for its fertility. And the consistent applications of this have led up to legacy phosphorus being built up in soil. And the phosphorus can be applied and applied and applied, but it isn't always plant available. Sometimes that phosphorus may bind to the soil surface matrices, And then another layer of molecules may bind on top, and then maybe there's another layer of phosphorus that binds to those molecules. And so you have this recalcitrant phosphorus that isn't available to plants. And then when you go to sample your phosphorus soil and you look at your nutrient content of soil, so the Delaware Soil Testing Lab, for example, this is a pie chart of Delaware soil test results. They've collected 5,600 tests from 2007 to 2011. They found that over 60% of the soils they tested had excessive levels of phosphorus, where you wouldn't recommend further phosphorus input. So if you have high phosphorus soil and it has the opportunity to move, that means that you're going to be moving this rich phosphorus source into your streams, which can then undergo different sorts of reactions. And so here we have some data from the Chesterville branch near Crumpton, Maryland, where we looked at phosphorus or sediment concentration. And so that is sediment is red, phosphorus is in blue, and the x-axis is stream flow in cubic feet per second. So as you have more stream flow moving through your system, you have more sediment and phosphorus transport. Converse is true for nitrate. Nitrogen or nitrate is the dominant form of nitrogen being added to Eastern Shore waterways and is primarily delivered by groundwater. And so when we have these rain events, that groundwater signature is diluted and concentrations of nitrogen tend to decrease. Increases in phosphorus and phosphorus transported soil from the field into the stream may be leading to increases in orthophosphorate concentrations. In the Choptank River, here we see a figure on the bottom right. This is from Finelli, Bloomquist, and Hirsch in 2019, where we look at orthophosphorus concentrations at different levels of discharge. There is a difference in the historical record compared to a more recent time period in terms of orthophosphorus concentrations. In the more recent time period, we're seeing higher orthophosphorus, which the authors link to increasing applications of manure within the watershed. So getting a better understanding of phosphorus and nutrient movement within the watershed, one of the most important factors that you can look at is input to the landscape itself. And there are different ways of estimating how much nutrients are applied to the landscape, both as atmospheric deposition or as a fertility treatment, or even from a wastewater system. And so when we look at commonly available data through the CAST system, which has been contributed to by different expert panels, and I'm not going to go into the calculations of CAST, it suggests that long-term, there's a decrease in phosphorus applications. But over the short-term period from 2009 to 2019, Delaware counties in particular may be seeing an increase in total phosphorus application. This may present a challenge in the future to decreasing phosphorus in our surface water. Pause there. We're going to move to nitrogen. So what is nitrogen doing? Much like phosphorus, most of the non-tidal stations on the Eastern Shore show increasing trends in both total nitrogen as well as nitrate. You'll see here that nitrate is a dominant form of nitrogen, and it makes up most of the total nitrogen that we see. At all these stations, we're seeing increases except for the Tuckahoe. Now, the Tuckahoe is interesting. It's showing a decrease of actually 2.4%. And this is the total nitrogen decrease is consistent with decreases in nitrate. What's important to know for nitrogen is how landscape factors can control nitrogen transport and how they may foster denitrification. We spoke a little bit about this earlier, looking at the aquifer thickness map and how nitrate remains stable in much of their superficial aquifer because of oxygen-rich conditions. In areas such as the Choptank, nitrogen loads are likely low due to hydric soils and a shallow water table, which promotes anoxic conditions and so denitrification. The nitrogen that is applied on the field is intercepted by these anoxic zones where bacteria use that nitrogen as a fuel source. The Nanocoke is different from that. Now, the non-tidal stations have different hydrology, different hydrogeology, and that is an important story here. The nanocoke lies on a thick portion of the superficial aquifer, and this allows for continued nitrogen transport from the land surface. It actually allows for a bypass of some of these anoxic zones. Now, the Tuckahoe is interesting as it's a mix in between these two in terms of both aquifer thickness and also in terms of travel time. When you look at the Tuckahoe total nitrogen loads, there's a difference in between the growing season and the non-growing season. Here I'm showing the work of Chen Zhang and Jimmy Weber, where they split apart the monthly loads into the growing season, non-growing season. What we can see here is this green line is the growing season in summertime. I believe they used from April through the end of September. And there you actually see increasing nitrogen transport. However, in the non-growing season, in your winter months, we're seeing a stronger decrease in nitrogen transport. And the lower fluxes that we're seeing in the wintertime months are overpowering the increase that we're seeing in the summertime months. And the Tuckahoe is also interesting as it's had a high enrollment of conservation practices, and CAS data suggests that there may be a decrease in nitrogen application. We know that there is strong cover crop performance, and this has also been linked to decreasing nitrate field losses. There's a couple of theories about what could be happening here. Is it that we have more green material on the land surface, increasing evapotranspiration and letting less water get through to groundwater during the wintertime months? Are we intercepting more of the shallow flow paths during wintertime months as our riparian zones are more active? Or is it a combination of the above with decreasing nitrate additions to the soil? We don't have a definitive answer. What we do know from work by Fox and others from 2021 paper is that they showed in subwatersheds within the Tuckahoe that there's they're seeing decreasing total nitrogen in base flow in these subwatersheds. And so the signal that we're seeing at the end of the watershed is shown by many areas, by many subwatersheds. Oh, and one of the questions that we had when we presented this to the Delaware interagency WIP planning call, we received a question of, okay, well, is there a difference in terms of our cover cropping practices? We see a jurisdictional difference in between these two. There's Maryland, which is the Tuckahoe, and Choptank is within Delaware. Is there a difference in between these two? And so we took a look at that cover crop performance, and we did that by using, there's a bit of methods to cover here. We did that by using Landsat. So satellites, you can measure greenness of the surface of the earth. And a researcher named Dean Hively and his group in Maryland have collected thousands of field samples of plants. And using those field samples, those collected plant samples, you're able to relate the greenness that you measure when you look at the earth with the nutrient content of the plant itself. And so by measuring greenness from a satellite, you're able to relate that back to biomass and see changes in biomass through time. And so this on the bottom right here, this image is from a paper we published in 2020, where we looked at the Tuckahoe, and you can see changes between years. You know, some years are better for cover crops. You know, cover crops don't perform on the same every single year. It has to do with the amount of temperature that they're receiving, which we describe in growing degree days and their variation. But when we look at different watersheds on the Eastern Shore, what we find is that they are responding relatively similarly in terms of their cover crop performance. So here we have on the left, here's the Tuckahoe, and on the right, here's the Nanocoke. And this is wintertime greenness, and this is NDVI, normalized difference vegetative index, which is a measure of how green the earth is. And so the blue dots are areas which we describe as row crop, and the red dots are all land, and the green dots are areas which are not row crop. We got those three distinctions by taking the cropland data layer and layering year after year on top of itself. What we assumed was that if in 9 out of 10 years, this was either corn or soybeans, we would call it row crop land. And if it wasn't, we would bin everything else into non-row crop land. Of course, there are issues with those assumptions, and I'd be happy to address those in the question and answer period. But for a rough cut of, is this cropland? Is it not cropland? I think we did okay. And what we see is that there are patterns that are similar in between the Tuckahoe and the Nanticoke, similar agroeconomic system between these two states. And the differences here are largely driven by temperature, but also cover crop implementation. We define 3 different periods of cover crop implementation. So prior to 2000 was relatively low implementation. From 2000 to 2010 was medium implementation. And from 2010 to 2020, we have high implementation. We define that high implementation and low and medium implementation by looking at enrollment acres within state, within Maryland state, Maryland's cover crop program, excuse me. So here's another one. So between Tuckahoe and Talbot County, once again, these all look relatively similar. The dashed lines on here, the bottom one is low biomass. The middle line is respectively medium biomass. And the dotted line on the top is high biomass. High biomass corresponds to about 8 to 12 pounds of nitrogen being held within the cover crop during winter time. And these are averages for the entire watershed. And so what you can see here is that in the most recent years, we are seeing strong cover crop performance, which means high biomass on our watersheds. And because these are relatively similar between Tuckahoe, looks the same as the Chester River, looks the same as relatively the same as the Nanticoke in terms of performance, I think it's reasonable to believe that in the Inland Bays watershed, you would see a similar pattern in terms of your cover crop performance. So one of the factors which can confound our seeing some of these management impacts is groundwater transit time. And it's going to it takes time for us to see a difference, at least in nitrogen, because what we would do on the landscape may take years to be realized in the stream. Stream water is a mix of different flow paths and ages. And it's a mix of different flow paths, different ages, different nutrient inputs from different time periods. But one thing we know is that the changes in the Tuckahoe will take a while to realize a water quality benefit to the bay. Fox and others in 2021 suggested that with the current rate of decrease in total nitrogen concentrations, it'll take about 53 years, plus or minus 11 years, for the Tuckahoe to reach the main stem of the bay's concentration. And so while we do see a decrease, it may be dampened by groundwater lag times. Looking to the future, what do we know about current inputs? As when we talk about nitrogen, our past is also our future in a way because of that groundwater and its movement. And so over the long-term period, we see CAST data suggesting that you have a large increase in nutrient application of nitrogen in the Delaware counties and some of the Maryland counties in the Eastern Shore. In the most recent period from 2009 to 2019, we see a less strong increase, but still an increase in terms of our nitrogen input to the land surface. And so if you're curious about what that information looks like, if you download the data from CAST, this is what it looks like through time. And you can get these estimates. These are in kilograms, and they'll show you an estimate of all applied nitrogen, of nitrogen need, of corn applied nitrogen, and of corn nitrogen need. And then on the bottom there, there's a purple line for manure nitrogen, which is reported as exported through the watershed. A little insight into the future. One of the programs that we have at the USGS is we work with the Delaware Department of Agriculture. And we have sampled a network of about 50 groundwater wells across the state. And we sampled these once in 2014 and sampled them again in 2019. And the goal of this network was to select shallow wells that were oxic so that they would conserve nitrogen. And we would like to see, and so they would be an indication of changes in land management practice. And after the first sampling, we realized that while all of these wells were in agricultural areas, they might not reflect agricultural water, as some of them have an urban water signature. And by that, I mean that there is more sodium and less of calcium, magnesium, and nitrogen. And so when we look between the two samplings of 2014 and 2019, we don't see a statistical difference in the concentrations observed in any of the three types of water. So some final notes there is, despite a long-term decline, stations are showing increasing sediment and phosphorus loads from 2009 to 2018. Nitrogen loads are increasing at all stations except for the Tuckahoe, and that there are management strategies which are being implemented now, but may be challenged by past current inputs into the landscape. And with that, I think we're almost at a half an hour. We had 68 minutes. This leaves us with 4 minutes if we cut the two speakers in half for questions.
Thanks, Alex.
I didn't put you to sleep.
Now we go ahead and open the floor for a couple of questions.
This is a picture of nutrient-rich nitrogen on the left and nitrogen-hungry corn in the middle.
Yeah, you folks see it on the screen. There's a little bit of a difference in coloration of that green there. All right, so I think Chris has a question.
Alex, do you mind going back to the slide you had with corn, need and application through time? I think it was
Not at all. Not at all, Chris.
Why are you laughing? You know where I'm going?
I'm pretty sure I do, but please continue.
Yeah. But, you know, it's striking when you're showing the geography of the Chesapeake Bay with regards to nitrogen and phosphorus inputs, and especially striking looking at the peninsula with regards to phosphorus, because Delaware lights up pretty bright, and Maryland looks like it's heading in the right direction. The implication being that Delaware might be more wasteful for phosphorus. But I just wanted to point out to the group that, you know, CAST is a tool that estimates these applications, and it's based on lots of background information, including things that are hotly contested, like fertilizer sales data, and what those maps don't talk about is the assimilative capacity. Because one thing that the Delmarva Peninsula is really good at is increasing assimilative capacity. We're the only region in the Chesapeake Bay watershed that's had a significant growth in irrigated acres, where everybody benefits from improved genetics in our crops. We're being even more efficient with our nutrients when we can judiciously apply water and artificial rainfall. So some of what Alex has illustrated here in the corn nitrogen need is going to be captured from irrigation, and the general trend across the slide from left to right that isn't influenced by the modern spike, I would say is probably heavily influenced by the genetic response, that we expect about 3% per year increase in yield just based on improved genetics in corn. And that almost always translates to nitrogen need at a rate of about 80%, but that's also highly contested.
Thank you for bringing it up, Chris, and everyone. So Chris and I got the email this morning. We both got stuck on a panel to look at these agricultural inputs and their use in the Bay model. So Chris, I look forward to working with you.
Yeah.
All right, well, given the our use of time right now, I want to switch us over to our last speaker. So Alex, thank you very much. If folks online have questions, I don't know if they're sticking around, but maybe they can put them in the chat or email them, and then folks in the room, you will make sure everyone has contact information to follow up if there are any other questions. So Dr. Lee, I guess sort of good that we were running late. We gave you time to finish teaching your class and get over here. We have a laptop up there. Did you want to switch into it, or did you want to pull your slides? I shared your Google slide deck with me. We could maybe open them up on that one. What do you prefer? Okay. Sure. And would you guys help her with we have a microphone too, so the folks online can hear. So there's a microphone that kind of goes go around your neck. Is that what it is?
Yeah.
Yeah. So we just ask that you project as loudly as you can so that everybody online can hear you. They were trying just like letting it sit on their neck. But does it go, can it sit on your, like that? There you go. I've never seen one like that before. So Dr. Lee, so kind of continuing with our water quality theme, Dr. Lee had connected with Mary Ann prior to Mary Ann's retirement. She has been involved with some water quality modeling efforts. And so her work was done also in portions of the Chesapeake Bay watershed, I believe. And so she was just going to share with us some of her lessons, successes, and what her group is working on. And so this is, you know, the type of individual and research group who could possibly help us with some of our water quality modeling pursuits in the future. So she'll certainly be getting an invitation to join our subcommittee. Give us 1 second as we get the slides up. Coming, guys, patient. For the folks online, while we're waiting for the slides to get projected, if you wouldn't mind, at the bottom of the agenda, you'll see that I was asking for some feedback on day of the week. So our STAC meeting dates for 2023 have not been set yet. And so if we switched to Wednesdays this past year. I want to know, I've heard from 1 or 2 individuals that there were some conflicts with them for Wednesdays, but overall, how did that work with folks? Is there a better day of the week? So you can just put down your thoughts in the chat, and then folks in the room, before you leave, please chime in for us as well. All right, so we see the slides are up. Thank you so much. Dr. Lee, please take the floor.
Good morning, everyone. I've been teaching in the past hours, so I'm sorry I'm late. I missed some wonderful talks, but I hope I can get to that point and help you understand why we're doing this modeling work here and how we incorporate data in our modeling exercise. So today I'd like to focus on Chesapeake Bay because that's where our past work has been focused on, and this is a work not by myself, by lots of people. And previous, the athletics we do that from the University of Maryland, where I used to do my PhD. And this incorporates my advisor, Dr. Lee from RCS, and Tasta, Joey Tasta, who gave a talk before here, I believe, and the David Ready from University of Maine. And also, back then we have Dr. Porto, that has been almost the entire team regarding the water quality modeling, coupled with the Earth's modeling framework. Okay, so today I'm going to focus on the lessons we learned from data and the success we developed on some new developments.
Really try to project as loud as you can. They're saying they're having a hard time hearing it. Is it coming out? Or?
Nothing's coming out of here.
Batteries instead?
It's got a blue light, so I don't like that button.
Hold on. We're charged.
Yeah. We could just
Could I move to that, please?
maybe step forward a few feet and just really try to project. Yeah, it's that.
Okay, I'm sorry if I block you. Okay. Right, so I will share some new developments after I arrived at UD since 2019. We have a computer lab here. We have new components added to this model. Next slide, please. So here is generally our computational oceanography lab, just across the street over there and the wind turbine. So we have undergraduate students who has been working on data analysis, and then we have graduate students who utilize our cluster system at UD to continue to refine, build up the model. And we also have postdocs working in this group, but not on this project. So the goal of this team to identify the key drivers and pathways and potential consequences of the ecosystem in terms of water quality, primary production. And we're not limited to any system. So that means Delaware Inland Bay is part of our next step plan. And we have previous work built up in Chesapeake Bay, in tropical region near Tampa Bay, and also we have ongoing work in both Arctic and Antarctic Ocean. All right, next slide, please. So our interest focuses on generally the coupling between biological and physical process. So with that being said, you can see the water quality issue is really interdisciplinary and covering both biogeochemistry, physics, and potential a lot of variability around this climate change. And I will trend mainly focus on the stratification circulation of Astron scale. And my thesis work built up on the Austrian dynamics, which is hypoxia, what I'm going to use as a showcase today. And we also have work in the cold water system and a hot water system. So either way. And in here, I show general concept. It's really the full lab. And our work mostly focusing on the highlighted boxes, the nutrient cycling, the primary production in the ecosystem. And next slide, please. So today I'm going to provide certain background, which is really biased because I want to focus on why the modeling is important to this work. And then I'm going to just briefly overview what is modeling world looks like right now and what do we have so far. So I'm going to use one case study in Chesapeake Bay, what lessons we learned after we have more data, the multi-stream data available, and why previous method doesn't work anymore. And what our success on building up new modeling that coupled with the Earth system model system. And here are some like ongoing work on coastal modeling if time allows. So this is my almost like a one slide introduction about why I'm thinking that ecosystem needs a modeling tool to address the unlearning dynamics. So for example, I showed across the locations from pool to top to equator and in Chesapeake Bay. So different systems I'm showing here as different like ecosystem phenomena and primary production or hypoxia, how for algal bloom. You can see that a clear record over decades that shows a lot of variabilities. Of course, we see the dominant signature that there's a clear signal cycle in most of systems that we can capture to the first order. But what we cannot fully address is really inter-annual variability and interseasonal variability as well. There are a lot of natural variability on top of human-induced variability. And also in some extreme cases, like the red tide and the vessel for a shelf, we also can see that the inter-annual variability already exceeds the signal variability, that we are lack of the dynamics to fully explain the occurrence of HAD over there. So generally speaking, just by eye, what's in here can be summarized by the four different regimes. We're seeing the change in the trend, in the magnitude, the timing of the events, and most of the systems associated with the frequency change. Like you have our seasonal bloom in spring previously, but now you may have spring and fall blooms in the system that give you a different story. Next slide, please. So here we have a general overview of the hypoxia system we studied before, and also in comparison to the literature. Next, please. Okay, so Chesapeake Bay is the case I'm going to use, but I don't want to limit the capability of modeling work to the specific type. So for example, in Long Island Sound and Narragansett Bay and South Lawrence Estuary, we do have different type of hypoxia. Some region marked by shallow water, and some region marked by strong signal hypoxia, but in the cold water system. And also what's not included here is really the shallow water we recently worked on, like Inland Bay. Or right now, there's another project in the New York region, talk about the small tributaries in the West along and the Sound. So we're now implementing the newest version of our model, try to address the nutrients loading and also the cycle in this region. Okay, next slide, please. So this gives you a scientific overview of what our team is doing. So our model can be summarized by these 5 bubbles in here. Generally speaking, for each bubble, there's individual model that we have to plug in to understand how the time scale and spatial scale couple with each other. So for example, we focus on primary production P and the nutrient cycling, and there are a lot of topics going on right now that not only reflected by the data, but also reflected by the theoretical consideration in the past. So for example, like when phytoplankton bloom will occur, if not a regular season cycle, what's really the driving force over there? And what the species composition, even though we have a bloom, is that dominated by large cell phytoplankton or small species, or even algal, harmful algal bloom species. And here, the nutrient cycling is not really a centric view. So there's really, we'll hear from previous talk, there are multi-species of nutrients going on. We have N, C, P, plus oxygen or other species that could coexist, co-limiting the system. Okay, next slide, please. Here is the general workflow in our lab that how we approach a question. So first, we start from observations because we believe this provide a first order information that defines the characteristic of the system. So usually we ask observation was a spatial temporal patterns, which I think I read the previous inland bay plan. The STAC committee recommended we incorporate the latest observation, which include both the long-term observation in low frequency plus the high frequency observation from the new sensors, which I think this overlaps with our goal because this data will tell us more and more dynamics that not considered in the previous hypothesis. And then we come up with hypothetical explanation. Next, please. So come with a hypothetical series which guide us to build our model. Because model is expensive. Okay, so it's the cost time effort is a one-time investment, but may last for decades for application. But at this moment, with clear information about characteristics of system, we're able to tailor our model to decide which part we do really need high resolution and refine the dynamics, which part we can neglect for this system because just for simplification become more cost effective. So next, this is some slide from working issue. So we construct the model, then we go back and test the observation to make sure the model is doing what are the input and what are the output, even though it's a black box. And next please. Once we have the full framework built up, we then can go ahead and address some high-level question like what's the management goal we're going to reach in the model? Like if you want to know the nutrient loading, if you want to know which location we can build aquaculture farm to receive the best benefits, or we can project into the future to see what could be the new pattern that can get us with the field work observation, where's the best location we can plug in our buoy. Okay, next slide, please. So generally speaking, right now, in the modeling world, you may hear there those different terminology, which defines the model. Like we have a cooking recipe. This is something we will start with. So we have different configuration, dynamics and scale. Everything leads from simplest to the highest complexity, which incorporate maybe our dollar sign, human effort behind each category. So right now we're at an intermediate level, but we're able to push the model to the more complex model if needed, that required either from the observation or from practical needs. Next slide, please. So here I'm going to show you our case study test case to generate like how we step by step improve the model and why that's necessary, why we put that effort and dollar on it to make this happen. So this is Chesapeake Bay hypoxic volume, and you may see this maybe counter times, but just a recap, it's a single occurring event in the main stem of Chesapeake Bay, only at bottom water. And the hypoxic volume has been ever changing, and the worst year is about 1/3 of the entire bay. Next slide, please. And previous study grouped the data using a statistical approach to look at how the river flow affect the hypoxic volume, because the concept is we have eutrophication, excess nutrient into the bay. And that grow phytoplankton, cause bloom, and then the deposition of organic matter to the bottom water will consume oxygen. Based on that concept, so previous models started to build up river flow with a hypoxic volume. Indeed, there's a clear characteristic they're related. So for example, after 1970s, there's a clear increase of nitrogen loading into Chesapeake Bay. That's due to the application of fertilizer. And then after 1990, seemed like the nutrient loading started to level off, but showing more variabilities interannually. Accordingly, from bottom data, even though we do not have continuous data, but the pattern is clear, we do have this long-term trend responding to that nutrient loading. But into more recent years, the regime is divided. So we have more severe hypoxia during wet years, but we have less severe hypoxia during the dry years. Seems like the river flow is playing some role in there. Next slide, please. However, if we use that river flow plus nutrient loading to predict the hypoxic volume, this is on the left. You can see the model doing an okay job, R-squared 0.2, means 20% variability gets explained, but not fully. We see still a lot of scatter along that plot. And the river flow by itself explained R equals 0.6, R-squared is 3.636, 30 to 40% explained. Okay, this is less than satisfactory because if this is used for management, then where the goal we want target for? So next slide, please. Then a newer study by Sally et al. And also Lee et al. Started to look at the data again, where they found that if you plug in the wind as a third parameter, this third player actually help both to improve. Which means now we seem to reach a higher level of satisfaction because we see the dramatic improvement of the strategic skill, just plugging a more dynamic parameter. The question is, why the wind is playing the impact? Because we think the nutrient not come from the wind, but from the river flow. So that means the bay itself is not a static system, it's dynamic. So the wind is actually bringing the mixing, the flow that affect the system, which like what we're talking here in Inland Bay. Even though we do have this nice gradient from the from the little creeks to the opening, but we do have the dynamics going on in the major lagoon that keep mixing or tidal flow coming and back and forth. So this indicates that a more closer look at the dynamics are needed. Next slide, please. And also, almost at the same time, that people recognize that we need more climate related index into the regime. And another study looked at the data. And interestingly, for every unit nitrogen input, they break the data down into different decades. So the light green color shows you 1950 to maybe the end of 1980. And you can see the whatever regression curve we were using is always lower than the curve you received between 1980 to 2000. So this clearly shows that there's a regime shift. So every unit of nitrogen input is actually creating more hypoxic events in the exactly same system. So which means if you use the traditional curve, statistically, how you can represent the same driving force, but a different regime. Are you going to use a new different statistical curve, but how you are going to do that predict into the future? So that means more dynamics need to be understood so that we can plug in more robust prediction into the future. Okay, next slide, please. So here shows you a general evolution of the consideration of the models used for Chesapeake Bay. Start from statistical models to the dynamic models. People think about the entire dynamical balance for the oxygen budget in the bay. So different models start to make assumptions, say others are not important. I'm only going to focus on the red box, which I think is a major source and sink of the dissolved oxygen. And you can see different lessons that were learned later on, and models start to become more and more complex because more dimensions coming in from the data. So there's no general agreement That's why I think in here, our Earth system model that incorporate most or all the processes can help us to tease out the non-important process versus important processes. Next slide, please. So here shows you general the numerical framework. We don't have to read the equation, but just let you know, the equation itself already lumps of the physical effects on top, incorporate mixing, advection at different times, spatial scales, and biological controls at the bottom. So different terms actually can be broken down into dozens of other terms, which I do not have to show. The concept here is really the coupling between physical and biological processes. Next, please. This is an overview of modeling framework we built up for the test-based system. So we have this high resolution modeling water mesh throughout the bay. The highest resolution about like 50 meters also. And recently we have empowered this modeling work, and we allow the model to go even higher resolution to be able to apply to like inland bay. We need a really fine structure to understand the details. And vertically, we have water layers allow us to identify the surface process versus near top nuclei process or bottom process. In the absence of stratification, like in the bay, we can focus on the surface and bottom with more higher resolution going there to help us understand the details. Okay, next please. So this is the biological module we utilize. This is a similar model developed earlier by Dr. Dom DePerro. It incorporates 2 to 3 phytoplankton groups, different organic matter groups, and N, P, and silica and other species for cycling. So those equations are already building, ready to use. And recently, the expansion of the model already incorporate new carbon cycle, and also different N2P ratio for harmful algal bloom, and also a seagrass model in here as well. Okay, next slide, please. So this shows you how we use the model to capture the observed data. So top is the river flow, shows you we pick up 10 years as our test bed. So we see the wet versus dry regime in Chesapeake Bay over that nice 10-year time period. And our model show in the red curve that we predict the time variation of hypoxic volume in the bay with the dots are instant in situ observation interpolated volume. So then you may ask, we have those dots, then why we need that curve? By observation, for example, the first is we can see the model is doing a decent job to reproduce observed pattern seasonally and interannually. We do have low hypoxia in the model versus high hypoxic volume built up on the contrast, which means the river flow impact is built in. And also, we look at the model closely, we do see this synoptic variability, which not captured by the data because it's monthly survey. But the model can go even finer time scale to take advantage of that to predict more fine structures. Even we break this down, then we can look at more details in spatial structure as well. So red is our quantitative measurement of the model performance. And reference point is at that black dots. You can see how close at each observation stations we can whole time series do our close comparison. Next slide, please. Then the next step is how to use the model. Once we have such an amazing tool, and it can help us to enrich the knowledge from the discrete observation, then we can start asking questions. The first question we have is, can we tease out anthropogenic versus natural variability? So the first step, we hold the nutrient loading from the river flow constant. That means we can vary the river flow, but that's only going to vary our stratification. Then later on, the vertical exchange of oxygen or exchange of oxygen through isolate circulation. But that's not going to have actual nitrate loaded into the bay. So that's actual excess nitrate. We consider that as human impact. We fix that loading, and then we start to see response like that. It's quite counterintuitive because supposedly we think the natural process will play some role, but actually the vertical mixing and horizontal action nicely compensate each other. Okay, that means in this system in Chesapeake Bay, the physical process has multiple pathways and they're compensating, making the human impact more straightforward. So the net impact mainly attributed anthropogenic nutrient loading. Next clip, please. So we can perform the perturbation now on anthropogenic nutrients. So there are different ways we can do the perturbation. This is just a simple experiment. We can double the loading and we can halving the loading to see the contrast. And most interestingly, it's not N or P itself plays the most important role. You can see when N and P together, the compounded effects really cause a nonlinear response, which means the treatment on nitrate may not be as effective as both nitrate and phosphorus together to reach the management goal. Next slide, please. And also, we can test on the climate variability through external forcing, like wind, and we can see how the different wind events affect the actual volume of hypoxia in the wind. And with that, we now understand the dynamics of dissolved oxygen, no matter through natural forcing or anthropogenic forcing. Then this model will prove the performance, then we can start to ask the management question. So this is one of the module we built previously. This is the previous publication 2013. We have a new one just published last year, 2021, talking about same framework that if you have a habitat model, then you have this hydrodynamic biogeochemical model can produce multi-layers of information continuously. So you can map the spatial coverage to predict where are the suitable habitat for certain species. Because if you have theoretical, physiological tolerance of the species, this can give us an envelope for each category, and then the composite will be the net effect. Next slide, please. So in summary, I think I showed that model, in addition to observation, help us understand more finer scale variability, like the synoptic scale. What I did not show is the spatial variability as well. And it can isolate climate versus human impact, especially in this case on DO, but other cases as well, like primary production, zooplankton, fish larvae. And we can use that to understand and predict ecosystem shift, because we're not relying on fixed statistical relationship, but on the internal dynamics. And we can ask sort of quantitative questions about management, like how much nutrient loading we need to reach a certain goal within a certain time scale. Next slide, please. How many minutes do I have?
We've got about 6 minutes till noon. Sorry.
All right, I have 3 slides ongoing work.
Okay.
So here we continue to push that model for more information. One ongoing work is talking about the speciation. As I mentioned, the model has multiple phytoplankton species, each represent different physiological response and metabolism. So in here, over the chain, we're able to use the climate condition to sort, like which species will become more dominant. Like in here in Chesapeake Bay, you can see that over long term, there are indeed less diatoms, more small species. So that indicates the efficiency of ecosystem or structure of the system is shifting. Next, please. This is another work we did in Tampa Bay. This is not my work. This is from my colleague, Bob Weisberg at USF. What they did is using similar model concept for the released particles from potential origins, I think. And then they can track the particles to where they go. This is where they did for the helpful algal bloom, the Cranelia brevis cells. A similar concept we applied in Chesapeake Bay. We release the larvae and we release organic matter, and we see where, like organic matter, where they will be deposited and where they consume the oxygen. Versus like larvae, like through the certain transition time, maybe 1 month or so, will larvae be able to survive at a certain location. So those modules can be easily turned on in this coupling modeling framework. Next slide, please. So this is something I talk about, the IBM is really now more popular in most of the coastal community because the advancement in computational power. So previously, we may not be able to see like more than 1,000 particles, but now we can push that envelope to 10,000 or even million particles over a certain experiment to help us approach the realistic condition. Final slide, please. Another thing I want to mention is we now have this capability of implementing this machine learning algorithm to guide our model. So that doesn't mean we want to use that to replace the human intelligence. Once again, we're using machine intelligence to help us reduce the labor. So that will make the model development much cheaper and more effective, efficient. For example, this is one model we built out for one of the poorly known parameter net community production in this Arctic coastal environment. So similar concept have applied here. If you have really not a lot of data, but enough data to be able to tell the regime, general statistical model won't be able to give us a really nice fit. This time, the machine can help us sort the relationship and provide the best optimization of the parameterization. And light is another challenge for modeling work. As you can see, I showed a multi-component model. Within that, we have 106 parameters. We have the two. You must be like wondering how I do that. We can't do that manually. First, we need a literature. Second, we need the machine to guide us. So their nice algorithm help us nudge the parameter toward the best knowledge, which means that is reflected in the literature. But each parameter has to be in its perfect space for the model to receive the best performance. Okay, so this is some new development ongoing in my lab. And overall, that's it for today. And just wanted you to know that we learn from the past, we learn from the new data, we keep pushing the model to a highest level, and we now incorporate multiple tools that can help us increase efficiency. Okay,
Thank you.
any questions?
Thank you for getting that all in that amount of time. I'm sorry if it felt rushed. Do folks have questions? Earlier we mentioned that because of the bipartisan infrastructure law, the center has put together a proposal for some of the funds that they'll be receiving. And they have allocated 500,000, I believe, for modeling for in the Inland Bays watershed. Several years ago, we put out a request for information. We got feedback that it would cost probably anywhere from 500,000 to a couple of $1 million, take multiple years. So we know that's probably not enough to really do a full scale hydrodynamic and water quality model. Plus, you reminded me there's things like habitat models you could add in and things like that, which would be useful and helpful. One of the things that we've talked about doing is, since we'll have somebody to kind of invest in starting this work, is identifying a focus area. Would we focus it on a certain portion of the Inland Bays watershed, or maybe it's a certain parameters to look at? And so I was just curious your feedback on that. Are there economies of scale? Would it make sense to only look at the Indian River versus the entire Rehoboth Indian River, Little Ass Bays, and have connections?
So I did submit a proposal to that call. Okay, so I will share my 2 cents on those questions. But then I did some literature review and look at previous data closely, which my thinking is, from modeling perspective, we can have one model for a little like Indian River region. But the thing is, it's equally costly for us to incorporate another system for comparison. From data perspective, I feel like your what is always biased because it may have unique dynamics. It may not have other influence. This is not the located using others. So from this perspective, I would think about using the entire system to start with. Because from a modeling perspective, if you have boundary, just select the cover domain, it's the same amount of effort to be going in and look at the entire system. Yeah, because for model, it's such a little increment. It's about incorporating doubling the area, tripling the area. But the benefit is once you have large area, you have complete physical dynamics. For example, you can have the technical human water all the way to human water. So you can do the full calculation. But if you have a certain region, maybe it's a part of freshwater system you were looking at, but that may not be immediately available to enrich the knowledge. You got other locations.
So folks said, I guess over in that point, if the room gets echoey, it's this acoustics in here. So just to briefly summarize, she said that it probably doesn't make sense to look at a small area because about the same amount of effort would go into modeling the entire system. So that's certainly something for us to keep in mind, and I think that's where we really need to hear from people who actually do modeling to inform our plans for the future. So are there any other questions as we have our last few minutes here? I mean, we're at 12:01, so if folks have to go, I respect that, and we can get up and leave, but if there are any other questions for Dr. Lee while we have her, let's use this time. Anybody? No? Okay. Well, thank you, Dr. Lee. Thank you, everyone, for joining us. We're going to adjourn our meeting for today. And as I said previously, we don't have dates set for 2023, so be on the lookout for them in your email. There was another message that came in. There is some sort of Halloween, I think, right? Megan, do you have any details on that? I think it's open and
It's a Halloween themed activity for your family and children from the James Farm on October 27th.
All right, so folks, on October 27th, there is a Halloween themed activities day at the James Farm, so it would be good for families. We will make sure to include that with our meeting minutes for you. So, but check it out, Google it, find it online. All right, thank you, everybody.